So you want to build yourself a PC, but you're not sure where to start? Well, don't worry, I've got you. In this video, I'm going to be showing you step by step how to put everything together. Once we build the PC, I'm going to be showing you how to install Windows, any drivers or programs that you're going to need. I'll show you how to set up the RGB software, how to enter the BIOS, update the BIOS, and adjust all the BIOS settings, including overclocking your RAM and adjusting any fan curves. So if you've never built a PC before, you've definitely come to the right place. I'm not going to be happy with just getting a guide that you can follow along to. What I want to do is make a guide that should you want to substitute a particular part, you're still going to be able to follow along to it. And not only that, but I'm going to explain why I'm using different parts. I'm going to explain why there's different options you can choose so you can make an informed choice about the components that go into your PC. So over the last year on the channel, I've done 35 builds with a whole variety of different hardware. So I know how to assemble everything together. I know what the common pitfalls are, and I'm going to be pointing these out to you today so you can avoid making the common mistakes. So at the end of the video, when you go ahead and flip that power button, you've got the best chance of everything working. Okay, let's make a start by taking a look at the case. So when it comes to picking a case, I think the first thing to think about is the size, and cases will range all the way from mini ITX cases, which are tiny, to mid-tower cases, which we've got here. And there is a bit of a difference. This is a slightly smaller mid-tower case compared to this one, and then we're up to absolutely massive full-tower cases. So if you are planning on doing your first build, the first bit of advice I would give you is stay away from mini ITX cases. They are much more complicated to do. You're going to have limited space to work in. It's going to be a much more difficult time fitting all your components in. And if you're doing your first build, I think a mid-tower case is the way to go. You're just going to find it much easier. Everything's going to be much cheaper as well, and you're going to have much more options. In terms of the mid-tower cases, what I find important in a case, obviously price to performance. You're going to want a good looking case with good build quality, good features, and comes at a reasonable price. And what I've got here is the Lian Lancool 207 and the Fantex Eclipse G400A, which were my winners of Case of the Year for 2024. So I can recommend both these cases. So if you do like these cases but don't like the colors, they both will come in black and white, so it's easy to change things up. And what I really like about these cases is they come with 4 good pre-installed case fans. There's no need to add any additional fans to either of these cases, so that's going to save you quite a bit of money on having to pick up additional fans and the headache of having to work out how to install them. Importantly, the fans in these cases are of good quality. The cases look good, and at the end of the build, I was happy with the thermal performance, the noise levels, and the aesthetics. So I've done the hard work for you. If you want to go with one of these cases, you're going to have a nice easy time, and I think you'll be happy with the end build. Although if you do want to go with something slightly different, you still should be able to follow along to this build guide with a few changes. So once you've got your case, the next thing to do is pick your motherboard, and the first thing I want to look at is size. So in terms of size, motherboards range from mini ATX up to micro ATX. We've got a standard ATX motherboard, and this is an eATX or extended ATX. So compared to a standard ATX motherboard, the eATX motherboard is slightly wider, but the same height. You really only tend to find these in premium, expensive motherboards packed with all the premium features. You've got more space in these motherboards, so the cooling tends to be better, and there's more space to fit additional features in. For example, we've got an M.2 slot on the side that there wouldn't be space on a standard ATX motherboard for. One step down from ATX is micro ATX. It's actually the same width, but it's a little bit smaller. And these tend to really only come in budget motherboards. You can see looking at this motherboard, the heat sinks aren't quite as good as these other boards. And then we come to mini ITX motherboard, which is smaller both in terms of height and in terms of width. And you would think with a smaller motherboard, everything's going to be cheaper. It's the complete opposite. Everything with mini ITX, it tends to be much more expensive than the standard ATX motherboards, which is the reason I've recommended this platform. So the first thing you're going to want to do is check your case manual to see what size of motherboard you can fit in the case. So our Lian case, the maximum that we can fit is ATX. So we can fit an ATX, micro ATX, and mini ITX. Now, if we go for any one of these smaller motherboards, it's not going to look great. Obviously, this tiny motherboard is going to be more expensive and it's not going to look good, so that's going to be a bad option. Micro ATX you might think is a good option because you're going to get this motherboard a little bit cheaper than the equivalent ATX motherboard. The difficulty is both motherboards are going to be mounted in the same position at the top, and you're going to have a load of space at the bottom of this motherboard. It will look fine before you plug the cables in, but once you start running cables coming up from the bottom, it's going to look untidy. So unless you've got a motherboard and you're trying not to buy an additional one, my advice would be to pick up an ATX motherboard for an ATX case. So our Fantex case will actually accommodate an ATX motherboard, but I'm not going to recommend you go out and get one. As I've mentioned, these tend to be high-end premium motherboards with generally more features than what you're going to need for the average build. And spending all your money on a motherboard is not what you should be doing. You're much better going with a middle to lower end motherboard and spending that extra money on your graphics card or your CPU to get the best performance. So if you're going to go with my recommendation of an ATX motherboard, the next thing you're going to decide on is, do you want to get a back connector motherboard? So you can see how this motherboard looks really clean without any connectors on the front of it. Whereas this standard board has connectors for our power cables, but also all our case and fan cables on the front of it. So it looks okay at the moment, but once you bring all the cables through and plug them in, it isn't going to look as clean from the front as this board. And if you take a look in from the back of this motherboard, you can see all the connectors are on the back of it. So you're not actually going to see any of the cables getting plugged in at the front. So the big advantage of these motherboards are in terms of aesthetics. Downside of these motherboards are that you have limited choice. There's only a handful of these from a few manufacturers. And the other problem is you're going to have a limited choice in terms of cases. So the Lian Li case that we've got does not support back connector motherboards, whereas the Fantex case does. So today I'm going to be showing you how to install both a standard motherboard and also a back connector motherboard. Importantly, in a case that does support back connector motherboards, you can of course use a standard motherboard if you prefer. So it is also possible to get a back connector motherboard in a micro ATX size. I just don't have any of those available, but it is important to check the specs of your case, whether it supports just ATX back connector motherboards or whether it supports micro ATX motherboards with back connectors, because the cutouts in the case are going to be in different places. So if you do want to go with a back connector motherboard, you're going to be able to get one from Aorus, Asus and MSI. Now, Aorus and MSI boards are fairly similar. The only cable that you're going to have at the front is a cable going into your graphics card to power your graphics card. Now, Asus have done something slightly different with their motherboards. They actually have GPU power connectors on the back of the motherboard. So you plug your power supply cables into the GPU connectors at the back of the motherboard, and then there's a little extra connector at the front of the motherboard beside the PCIe slot. And if you use one of their special graphics cards, it's going to get power through this connector. So there's no actual cables to plug into the front of their graphics cards. It is still possible to use one of their motherboards with a standard graphics card. In that case, you don't plug the cables into the back of the motherboard and you simply plug the standard power cables into your graphics card at the front. So two more things to decide on are the color and the manufacturer, and most manufacturers offer a range of motherboards in black and white. If you're wanting to go with a black build, you'll probably have a bit more of a choice than you will with the white parts, and sometimes the white parts do come at a little bit of a premium in terms of price. In terms of manufacturer, I've used a lot of Asus and Aorus motherboards on the channel over the last year, and they've all been rock solid. My advice when it comes to picking a manufacturer is think what you're going to be using for the rest of your components. If you're going with an Asus graphics card, an Asus motherboard probably makes sense. And if you're going with an Aorus graphics card, an Aorus motherboard probably makes sense. And the reason is that one software package is going to be able to control both your motherboard and your graphics card's RGB. What you don't want to do is have a whole range of different manufacturers in the build. It doesn't look quite as well. And when it comes to control and everything, you're going to have a whole load of software running, which is going to be a bit of a headache. So the next thing to decide upon is what CPU you plan on using in your motherboard, because if you're going to go with an AMD CPU, you're going to need to use an AMD motherboard, and if you're planning on using an Intel CPU, you're going to need to use an Intel motherboard. They aren't going to be interchangeable, and we'll cover the CPU more on the next section. So no matter whether you want to go with AMD or Intel, what is important is what socket does your motherboard use. So the latest AMD motherboards use an AM5 socket, so you're going to want to use that with an AM5 CPU. The previous motherboards were AM4 and they used a different type of CPU, so you can't install an AM4 CPU in an AM5 motherboard. Likewise, if we move over to Intel, the latest socket is LGA 1851 and the socket before that was LGA 1700. So you can't pick an LGA 1700 CPU and put it into the latest motherboard. You're going to have to make sure the CPU is compatible with the socket you're going to be using in the motherboard. So in this build guide, I'm going to be showing you how to install the latest hardware in the latest platforms from both AMD and Intel. If you do want to go with older hardware from previous generations, you can check out one of my earlier build guides. So both with AMD and Intel, they have a high-end chipset. On AMD, it is the X870 and X870E. On Intel, it's the Z890. They have a budget-oriented chipset, which is B850 on AMD and B860 on Intel. Big differences between the two platforms. The first is obviously the price. The flagship one is going to have the higher price, and at that price you get more features. And those extra features come because you've got more PCIe lanes on the motherboard. And that means you can have more things like faster Gen 5 storage. You're going to have more drives available for that. You're going to have more USB ports and other features on the motherboard. What I would say is the B850 and B860 chipsets do tend to offer enough features for the average build. So look really closely at the motherboards and see what each of them offers. And you might find actually your money is better spent on the cheaper chipset, meaning you've got more money for your CPU and your graphics card. One thing to mention about Intel is that on the B chipset, you don't tend to be able to overclock your CPU, although you can overclock your RAM, whereas on AMD, you are still able to overclock both your CPU and your RAM on B850. So I think the most important thing to say about motherboards is don't overspend on your motherboard. The difference between the same CPU installed in a budget motherboard compared to a high-end motherboard is going to be a few percent in terms of performance. So my advice is look at the features each of the motherboards offer, find one that you like the look of, that has good reviews, and save your money for more important components in your build. So today I'm going to be showing you how to install both an Intel and AMD motherboard. We'll have one black, one white, we'll have one with back connectors, and we'll have one with standard connectors. And if you want to go with something different, you still should be able to follow along to this build guide. So now we come on to our CPUs, and as we've mentioned, if you're going with an AMD motherboard, you need an AMD CPU that's compatible with a socket, and likewise with Intel. You might have a bit of difficulty comparing the latest generations because you'll find that a lot of the Intel Core Ultra processors seem to have more cores, and this is just a difference between how Intel and AMD have set up their latest desktop processors. So AMD just goes with all cores the same. They're all big cores for heavy lifting, whereas Intel has this hybrid architecture. There's P cores for performance and E cores for efficient. The P cores do the heavy lifting, where the efficient cores do more of the background tasks that require less power. So it is difficult to compare them directly on a core count. So the way I like to look at it is take the efficient cores as bonus cores and look at the P cores that the Intel CPU has, and that will help you slightly compare between the different platforms. The best way to compare them is to look at the benchmarks. What do you want to use your PC for? Is it going to be a gaming PC? Look at the gaming benchmarks, head over to YouTube and the games that you want to play, compare the different CPUs and see the difference between the performance that you get compared to the price that you're going to have to spend. If you're using it for productivity, video editing, Puget Systems is a great source of benchmarks. That's where I go to when I'm building a video editing PC to see the difference between the different CPUs and GPUs that's going to make and help me decide what I go with. So to give you a quick starting point, if you are planning on building a gaming PC, you can probably still get away with a 6-core CPU. Although if your budget will stretch to it, I would recommend trying to get at least an 8-core CPU. It's going to future-proof your PC a little bit, and if you do want to use it for other tasks, for example, a little bit of video editing, it's going to perform better in that. If you're building a PC purely for video editing or other productivity tasks, you're probably going to want to look at going up the cores, but like I say, the benchmarks are going to help you decide what you need to go with. So if you are building a gaming PC, in general, the most expensive component in your build should be your graphics card, and that's where the majority of your money should go. And while I've told you don't overspend on your motherboard, one thing I will say is don't underspend on your CPU, because you could potentially be creating a source of bottleneck. A bottleneck is where one component in the system holds back other more powerful components. You don't want to overspend on your CPU, but you want to make sure you're not creating a bottleneck with your CPU, and you want to have a reasonably balanced system. And I think if you're going with a reasonably modern 6 or 8 core CPU, it should handle a fairly powerful graphics card. And again, as I mentioned, I would probably try and err towards the 8 core CPU if possible. So if you do want the very best in gaming performance, AMD's X3D CPUs with 3D V-Cache are probably what you want to go with if your budget can handle it. There's the new 9800 X3D, and the previous generation had a 7800 X3D, and these are without doubt the best gaming CPUs on the market. The downside of these CPUs is availability and pricing, and actually whether that extra price that you're going to pay to get that best performance is worth it. that's going to have to be up to you to decide again by looking at the benchmarks. But if you do have deep pockets and you want the absolute best in terms of gaming PC, it's the X3D CPUs from AMD that you should be looking at. So you might be wondering, can I use the latest and greatest CPU with an older motherboard to save myself some money? Well, the answer with Intel is no, because the Core Ultra processors are the first generation of this CPU, so there's only one set of motherboards that are going to be compatible with this CPU. In terms of AMD, you do have a previous generation of motherboards. They're the X670 and X670E and the cheaper B650 chipset. So these CPUs will work in those motherboards with a BIOS update. So that is one way that you can save yourself some money. And that's one of the things that I'm going to be showing you today. So I'm going to be installing this 9700X, the latest CPU, in a B650E motherboard. So this is a previous generation of motherboard. One issue you may run into is BIOS compatibility, because obviously whenever the B650 motherboards came out, the 9000 series of CPUs didn't exist. So there generally needs to be a BIOS update done before the CPU will work, and you might actually need to flash your BIOS before your PC will work after you've assembled it. But don't worry, I'm going to cover all this in this video, and I'll show you how to do this later on. So you might be wondering, should I go with Intel or should I go with AMD? And I am going to share my personal recommendation to you, and that's based on the reviews the CPUs have and also the forward compatibility. In terms of the reviews, the latest generation from Intel has been pretty lukewarm. I have built PCs with it and I've been very happy with the performance, but in general, most people would recommend AMD at this current moment in time. The other big advantage that AMD is going to give you is the AM5 socket is going to be supported right through to 2027 at least. So you're going to be able to pick yourself up an AM5 motherboard and potentially be able to drop a new CPU into it over the next couple of years. Compared to this with Intel, we're not sure if the next generation of CPUs is going to use the same socket. So you might buy this and find actually to upgrade your CPU, you're going to need a new motherboard. So for those two reasons, if I was picking up one, I probably would go with one of AMD's latest processors, although I will show how you to install both in this build guide. So if we take a look at the back of the motherboard, you'll notice there's lots of little bits of metal protruding from it. So you were to set this down on your table, there's a really good chance that you're going to end up scratching your table. So the motherboard that I'm actually using for our black build is a really high-end motherboard. It comes with this metal backplate which helps protect the back of the motherboard and provide extra rigidity. So we're not going to have to worry about damaging our table, but it still is good practice to set the motherboard down on its box. So this is the Asus ROG Maximus Z890 Hero motherboard, which is an Intel board, and you'll find links to all the products I've used in the description. So the first thing we're going to do is install our CPU, and our socket is behind this black protective bit of plastic. So we're going to need to open our socket cover, and to do that we're going to push this lever down and out. We can bring it all the way to the top of the motherboard, and then we can open the socket cover up. So this is our LJ1851 socket, and if we look in the socket you'll notice we've got lots of little pins. Now what's really important is when we're installing our CPU that we don't damage these pins, because if we actually bend these pins out of shape, it could be the end of our motherboard. The other thing to point out, if we look carefully at the socket, there's a little notch here and a little notch here, and they're going to line up with notches in our CPU, so we're only going to be able to install the CPU in the socket the correct way up. So this is our Core Ultra 9 285K, and you notice if we look at the top and the bottom, there's a little notch in the CPU which is going to line up with the notches in the socket. You'll notice the text is the correct way up, and that is the way we're going to want to install it into the socket. The other thing is you'll notice I'm holding the CPU by the sides, and that is because I don't want to contaminate the gold contacts at the bottom. So I do find the easiest way to orientate the latest generation of CPUs in the socket is just to have the text up the correct way round. But if you look at the bottom left hand side of the CPU, you'll notice there's a little triangle on it. And if I close the socket again temporarily, you'll notice we've got a little triangle on the bottom left hand side of the socket. So the two triangles are going to line up, or as like I say, the easiest thing is just install the CPU with the text the correct way up. So all we're going to want to do is hold the CPU by the edges, the text the correct way up, and lower it down gently into the socket. If it doesn't fall into straight away, we're going to move it back and forth and side to side. Once we have it in the socket, the notches here are going to line up with the notches in the CPU. To make sure it's properly installed, just a little wiggle from side to side and up and down. And if there's no movement in it, it's correctly installed in the socket. Then what we're going to want to do is close the socket cover down. And then we're going to close this lever to secure the cover. Now, I'm going to warn you about this because if this is your first build, this will alarm you. This black bit of plastic is going to pop off. It can pop off quite dramatically, going all the way up in the air, or it may just pop off, but it is going to make a noise as you close the socket cover down. So we just close the lever, and that's our CPU installed in the socket. So this little cover here, you're going to want to put that into your motherboard box, because if you ever take the CPU out of the socket, the pins are going to be at risk of getting damaged. So you're going to have to put this plastic cover back on again. So as I mentioned, I'm going to be showing you how to do an AMD and an Intel build. This is our AMD motherboard, and it's also a back connector motherboard, so we've got all the connectors on the back. So although it does have a back plate, a lot of these connectors protrude past it. So we're going to have to be really careful we don't damage any of the pins. And the other thing is take care not to cut yourself, because if you're putting your hand underneath to lift this up, there's a really good chance these RGB pins, for example, can really cut into your hand. So just before we open the socket cover up, you notice we've got this triangle on the top left-hand side, and that's going to line up with a mark on our CPU. So we can go ahead and push the lever down, bring it all the way to the middle of the motherboard, and then we're going to be able to open the socket cover up. Again, with the socket cover opened up, you've noticed we've got this gold triangle again at the top left-hand corner. Similar to our Intel socket, we've got all the pins in the sockets. We're going to have to take real care not to damage these. The Intel motherboards, you can sometimes bend the pins back into position if you have bent them, although it's not easy to do. It's almost impossible in these M5 sockets to put the pins back into line, so take real care you don't damage them. Again, we've got a little notch here and a notch here, which is going to line up with notches in our CPU. So this is our AMD CPU. It's in 9700X. So you can see the gold triangle at the top left-hand corner, which is going to line up with the mark on the socket. And as I mentioned, the easiest way with this latest generation of CPUs is just to install them with the text the correct way up. This doesn't apply to older generations where sometimes the text was on its side. Again, on the underside, we've got that gold triangle, which when we turn the CPU round, it will line up with the mark on the socket. And we've got little notches in the CPU, which are going to help line up with notches in the socket. So we're just again going to lower our CPU down carefully, text the correct way up, and holding it by the edges. If it falls into the socket, great, and if it doesn't, with just a little wiggle, and that's got it to fall into place. Before we close anything, we want to check it's sitting correctly, and the easiest way is just to slide it up and down, there's no movement, and side to side, there's no movement, and those two notches are holding the CPU in place. We can then close our socket cover down, and again, don't be alarmed if the white bit of plastic pops off. So not quite as dramatic as on the Intel board, but we're still going to put it in our motherboard box for safekeeping. Next thing to look at is storage, and I'll cut straight to my recommendation, and that is a Gen 4 NVMe drive. These are simple to install and offer brilliant price to performance. In terms of NVMe drives, we do have them in Gen 3, and we also have them in Gen 5. And the speed has obviously gone up as the generations go on. So you might be wondering why I'm not recommending Gen 3, and that is there's not that big of a difference between a Gen 3 and a Gen 4 drive in terms of price, but there is a good bump in terms of performance. So that's why I would generally leave the Gen 3 drives. Another thing to be careful, particularly going towards the budget end of the market, it is possible to get a SATA M.2 drive, and it is even slower than a Gen 3 drive. So that is something you definitely do not want. So you might be wondering why I'm not recommending the latest and greatest of Gen 5 drives with their blistering fast speeds. And the simple answer is real world performance and price to performance. These are much more expensive than the Gen 4 drives. If you run the benchmarks, they do offer a significant benefit in terms of performance, but in doing real world tasks, there's not actually that big of a difference between the two, and certainly not the jump you're going to get from going from an NVMe to one of these older modalities. The other issue with these drives is they run much hotter, and when you look at the Gen 5 slots in the motherboard, they come with a really beefy heatsink, and actually this particular model came with this really beefy heatsink with a fan on it to actually cool the drive down. So you're going to pay more for these, and I don't think in real world performance you're getting an awful lot of benefit. So for me, the sweet spot is the Gen 4 drive. So what about this 2.5-inch SATA SSD? So it's still an SSD, similar to what we've got here, but there's a different connection to your PC. So we've got two connectors, one's for power and one is for a SATA data cable that plugs into a SATA port on your PC. And the big downside of these is that connection, the moving data to and from the drive, is significantly slower than NVMe. In terms of price, these actually aren't an awful lot cheaper than your NVMe drives, particularly Gen 3 or Gen 4, so it's hard to recommend them. The only place they might come in useful if you have limited M.2 slots on your motherboard and need to add more storage in. They're a great way of doing that. But in general, your first choice should be an NVMe drive. So what about a mechanical hard drive? This is a 3.5-inch one, but they also do come in 2.5-inch size. So this works over the SATA interface, the same as the SATA SSD, but it has lots of moving parts in it, which makes it incredibly slow. The other downside of it, because it's got these moving parts, you can actually hear it and it's quite noisy to have in your PC. Main advantage, however, is it is significantly cheaper than the other forms of storage. Really, the only place it serves purpose for me would be in long-term storage and files that you're not going to have to access that often. And I do have these in my NAS, but it is a separate computer. And I couldn't stand to have this part on in my main PC because you would hear it over all the fans in the system. And I just can't stand the noise of it. So as far as my thoughts on mechanical hard drives, I wouldn't have it anywhere near my PC because the speed is too slow for what we're getting with the alternatives and I can't stand the noise. But if you do want to have it in your PC, whatever you do, don't install Windows on it because it will take an absolute lifetime to load and the performance of your PC will be significantly hampered. If you must have one, just use it for long-term storage, but make sure you install Windows on an SSD. Last thing to mention on storage is if your budget allows it, I would recommend having 2 different drives in your system. So you're going to have one smaller capacity drive that you install Windows on, and another drive that you have your games library on or keep your files on for video editing. The reason for this is to improve the performance of your PC. If you have all your games library on the same drive as your operating system and you end up filling it up and space becomes limited, that is going to hamper the performance of your PC. Whereas if your operating system's on a separate drive, it's not going to get impacted by you filling up that games library or filling up the file with video editing. For example, if you are video editing and you're having to pull a lot of files in and out and reading them right into the drive and your operating system is running on the same drive, that is also going to hamper the performance of it. So if you have the budget for it, I would recommend 2 drives, a smaller drive for your operating system and a slightly larger drive for either games library or your files for video editing. So the next thing for us to do is install our M.2 SSDs, and our M.2 slots are behind heatsinks on the motherboard. So you'll notice our top slot has this really beefy heatsink in it, and that's a good sign that it's going to be a Gen 5 slot. As I've mentioned, the Gen 5 drives run much hotter, so you do need a really beefy heatsink on them to prevent them from throttling. So to remove our top slot, it is toolless, so we're going to push this lever down. We can then lift it up and pull the heatsink away. The rest of our M.2 slots are underneath this bottom heatsink. It's held on with 4 screws. Then with the screws loosened, we can lift the heatsink off. So this is a high-end motherboard. It actually has 6 M.2 slots. There's 1, 2, 3, 4, and 5 and 6. So all of these slots aren't created equally, so it's really important you have a really good look at the motherboard manual to see the spec of each of the slots and is there any compromises if you install a drive in each of the slots. So our motherboard has 3 Gen 5 slots. They are the top one and these 2 bottom slots on the left-hand side, whereas the other 3 slots are Gen 4 drives. So the first question you may have is, can I install a Gen 4 drive in a Gen 5 slot? The answer is yes, you can, but you mightn't get any advantage from doing it. The drive's not going to run any faster than its generation. Likewise, you can put a Gen 5 drive into a Gen 4 slot, but that is going to hamper its performance because it's only going to be able to run at Gen 4 speeds in a Gen 4 slot. The next thing you're going to want to look at is where do the PCIe lanes for each of the slots come from. So all the ones over towards the left-hand side, they come directly from the CPU, whereas these 2 slots over on the right-hand side, they come via the chipset. So although these slots are Gen 4 slots, they're going to be slightly slower than this Gen 4 slot because it goes directly to the CPU, whereas these ones have to go via the chipset. You're then going to want to know, is there any compromises if I occupy any of the slots? And this varies from motherboard to motherboard, and particularly with older Intel generations, they tended to have 1 Gen 5 slot, but if you installed a drive in it, it tended to reduce the PCIe lanes from your graphics card down. So with this new generation of boards, the good news is if you install your Gen 5 drive in this top slot, there's no limitations for your graphics card. You've still got all 16 Gen 5 lanes for your graphics card. The problem comes with the next 2 Gen 5 drives down. They share PCIe lanes with this top slot. So each of these requires 4 lanes. So if you install a drive in any one of these slots, The 16 lanes that you have for your graphics card are cut down to 8 because they're going to use 4 of them each. The other question I'm often asked, does it matter if I put a Gen 4 drive in these slots? No, it doesn't. Any drives installed Gen 3, Gen 4, Gen 5, you're going to reduce the PCI lanes from your graphics card down. And then the final thing you're going to want to look at with the different slots is how good are the heat sinks on them. In some more budget boards, you might not even get a heatsink on them. In these boards, we've got heat pads behind these slots here, but no heat pads behind these slots. So factoring all this in, I'm going to be installing one Gen 5 drive and one Gen 4 drive. So in terms of the Gen 5 drive, it makes sense to install this in the top slot. That's because we don't want to reduce the PCI lanes down for our graphics card by using this bottom slot. The other advantage of the top slot, it has a much beefier heatsink than this bottom slot, so it's going to help our drive run slightly cooler. In terms of our Gen 4 drive, this is the slot we're going to install it in for 2 reasons. The first is we've got a little heat pad behind it, which is going to help cool our drive, whereas these Gen 4 slots don't have that. And the second reason is the PCI lanes for this slot come directly from the CPU, whereas the ones over here come via the chipset, so this is going to be the faster slot. And in general, in most motherboards, it tends to be the top slot that is the fastest one. But if you are going with a different motherboard, it's just really important you look at the manual to help you decide which is the best place to install your drives. So just before we install our drives, we're going to want to remove the plastic protection from the heat pad, and though we're only going to be installing drives in these 2 slots, it probably is good practice to remove all the plastic pads because there is going to be quite a bit of heat next to here. Likewise, we're going to need to remove the plastic protection on the back of the heat sinks. So you'll notice our M.2 SSD has gold contacts on one side, and we're going to slide that into our slot. So all we want to do is hold the drive at a slight angle and insert it into the slot. So once it's in the slot, we can go ahead and push it down. Now we've got this little clip here, which we just need to push forward, and that's then going to secure our drive in the slot. This clip will slide to different positions for different lengths of drives, and once it's in the right place to remove it, all you need to do is pull it slightly this way, and that will free it up, and then it's just a simple matter of pushing it down to lock it in place. We can then work our way down to our Gen 4 slot, slot the drive into place, and again we've got a little clip here which is going to hold it in place, so it's just a matter of pushing the drive down. So another important tip to give you at this stage, if there's one particular drive that you want to install Windows on, and for us it would be our Gen 5 drive, and you've got drives of the same capacity, for example, if these were both 1 terabyte drives, there would be no way for us to identify which drive was which when we come to install Windows. So the safest thing to do in this situation would just be to install the one drive, install Windows on the drive, and then at a later stage add the additional drives in. For this particular build, our Gen 5 drive is a 1 terabyte drive, whereas our Gen 4 drive is a 2 terabyte drive. So when we come to set up Windows, we can just look for the 1 terabyte drive and install Windows on it. And then we can go ahead and replace our heat sinks. So just to give you a look at a more budget oriented board, so this motherboard has 2 M.2 SSD slots for drives. There's one behind this top heatsink and one down here. This one that's labeled M.2 is actually for a Wi-Fi module. So if we only had one drive to install, the best place to install would be the top slot behind the heatsink. And if we were needing to install a second one, we would install it down here. And one thing to consider might be picking up a drive that had a heatsink already attached to it to help the drive run nice and cool. So the process to install the drive in the slot is exactly the same, but you'll notice here we don't have any fancy clips for securing it. So we would simply need to flatten the drive down, take a screw from the motherboard box and secure the drive into place. So moving on to take a look at our back connector AMD board. So we've got 2 heat sinks. There's one over the top M.2 slot, so there's a little lever we just need to push up, and then we're going to be able to tilt the heatsink up and lift away. Again, we've got a lever here, so we pull the clip down, we're able to lift the heatsink up and slide out and up. So this motherboard has 3 M.2 SSD slots. The top one is a Gen 5 slot and the bottom 2 are Gen 4 slots. The PCI lanes for the top 2 slots come from the CPU, and the PCI lanes from the bottom slot come from the chipset. And there's no compromises at all. We can put drives in all 3 of the slots and there's no limitations. So I'm planning on installing 2 Gen 4 drives in this motherboard, so there's no reason why we can't put a Gen 4 drive in this top Gen 5 slot, although it will only run in Gen 4 speeds. And this makes sense because the PCI lanes for these top 2 slots come from the CPU, and it means we should use these rather than the bottom ones that come from the chipset. So I'm going to take our 1 TB drive and install it into the top slot, and then if we flatten it down, this little clip's going to hold it in place. And then we'll take a 2 TB Gen 4 drive, install it into the second slot, push it down, and the clip is going to hold it in place. Again, we need to remember to remove the plastic protection from the heat sinks, and then we can replace our top heatsink. I'm not going to replace our bottom heatsink just yet, and the reason for that is the heatsink actually hides the screw holes in the motherboard, so we're going to need to wait until we've screwed our motherboard into the case before we replace the bottom heatsink. And in fact, we've got a few other magnetically attached covers in the top half of the motherboard that are hiding screw holes, so we'll go ahead and remove these at this stage as well. So this brings us on to our RAM, and if you're using the latest platforms from both Intel and AMD, it's going to be DDR5 that you want. The previous generation from Intel, some motherboards would use DDR4 and some would use DDR5, but the latest platforms from both AMD and Intel are all DDR5. So like with your motherboard, you're going to have a range of color choices, the commonest being black and white, and you can pick a color that's going to complement your build. The RAM comes both with and without RGB. An important thing to consider is, do you actually want RGB on your RAM? If you're going with a big air cooler that's going to block the RAM, there's probably not much point having RGB on it. Although if you want to move to another system in the future and install an I/O, you may well appreciate having the RGB on it. Another thing to consider is if you are going to have RGB on it and you don't install any software, it's going to run in rainbow mode. And if you want to change it to something, you are actually going to have to use software to control the effects on the RAM. Either your motherboard software, or actually sometimes the RAM manufacturer will have their own package that allows you to adjust the colors on it. But if you do want a PC with a minimum amount of software on it, that's something to consider. You might want to pick RAM without RGB on it. So when it comes to picking a kit of RAM, there's three major things to consider. The first is the capacity, the second is the speed of the RAM, and the third is the latency. In terms of capacity, I would recommend a 32GB kit for building a modern PC in the latest platforms. It still is possible to probably get away with 16GB, but how long you can do that, it's going to be determined, and you do probably want to future-proof your PC a little bit. And given it's not particularly expensive to go from 16 to 32, it would be my recommendation for a new gaming PC to go with a 32GB kit. In terms of the speed of the RAM, the higher the speed, the better, and generally the sweet spot is round about 6,000 megatransfers per second. You may get benefits going above that, but again, the price per to performance tends to diminish. And if you are thinking of doing that, it's probably worth looking at the benchmarks to see, is your money better spent here, where it probably isn't, and actually your money is probably better spent on your graphics card or your CPU. Final thing to look at is the latency, and in general you're probably looking for that to be in the low 30s if possible. The lower the latency, the better. Another thing you might be wondering, is my RAM kit compatible with my motherboard? So most motherboards will have a QVL or qualified vendor list, so you're going to want to check and see is your RAM kit on that. If it is, you shouldn't have any problem running your RAM at the advertised speed. If your kit of RAM you're planning on using isn't on that list, it's probably still going to work on your motherboard, but you might not be able to get that advertised speed from it. What you do when you put your RAM into the motherboard, it doesn't run at that speed that's advertised on the RAM, and you're going to have to enable either the XMP on Intel or the Expo on AMD to get the RAM running at that faster speed. And if it's not on that list, it's not guaranteed that that is going to work. So you're always better to pick RAM that is on that list. Another thing, when you look at that list, you'll notice that the faster speeds you tend to get in a kit of 2 sticks compared to 4. And that's why would be my recommendation to go with 2 sticks of RAM. So you want 64GB of RAM, pick up 2 32GB sticks, because you're going to probably have an easier time. It's going to be cheaper, as you're going to get that faster speed without any issues. If you do really like the aesthetics of 4 sticks, my advice would be to buy a kit of 4 sticks of RAM. You don't want to buy 2 sticks at one point and then get another 2 sticks and add them in, because they are not guaranteed to run together at those faster speeds. Chances are if you plug the 4 sticks in, they probably will run, but you may run into issues when you try to enable the Expo or the XMP profile, and it may not run at those advertised speeds. Final thing to mention on RAM, if you're going with an AMD motherboard, try and pick up the kit that says Expo on it, and if you're going with an Intel build, pick up the one that says XMP. You still probably will be able to run an Expo kit of RAM in an Intel system and an XMP kit in an AMD system and still get them to run at the advertised speed, but the best way to guarantee it is to pick up the right kit for the right system. Expo goes with AMD, XMP goes with Intel. We're now ready to install our RAM in the motherboard. So our kit has 2 sticks but we've got 4 slots on the motherboard, so we can't just pick and choose which of the slots we install it in. Your motherboard manual will tell you which ones to install it in, but if we also look on the motherboard, there is normally a little diagram telling you which ones to install it on. Unfortunately, on our Intel board, it's covered with another sticker, but you can see it on our AMD board. So in general, it is the 2nd and 4th slot along from the CPU, which are A2 and B2. And you're going to have to install in these slots if you want your RAM to access dual channel. So this is our stick of DDR5. You'll notice we've got gold contacts down at the bottom with a little notch in them. And you'll notice the lengths of the gold contacts are different. So it's only going to go into the socket one way round. In general, you're going to have the good side of the RAM facing the right-hand side of the motherboard. If I turn it round, there's the side with a little sticker on it, and it tends to be facing towards the CPU. But you can't rely on this. There is some kits of RAM that have it the other way round. Another important thing to mention, if you've got a DDR5 motherboard, don't try installing DDR4 in it. It won't fit and you will damage both the RAM and the motherboard. Okay, so we're going to go ahead and open the clips on the 2nd and 4th slot along from the CPU. Some motherboards will just have clips at the top that open. This particular motherboard has clips at both the top and at the bottom. Next thing we're going to do is line our RAM up with the slot. Now importantly, we have to make sure it's round the right way. This way round, the little notch fits up with the slots. If we turn it round this way, you'll see that the notch doesn't line up with the slots. Now, if we try to install this, we would damage the RAM and the motherboard. So what we're going to do is have the RAM round the right way, and we're just going to slide it into the slots at the top. And then we're going to let it fall down into the socket. Next thing you're going to want to do is apply some firm pressure to the top of the RAM on both sides. It's going to clip into the slot and the little clips are going to close on both sides. And this would be the most common reason that your PC isn't going to work at the end, is that you haven't actually installed the RAM correctly. So make sure you're applying firm pressure, and once you've checked you've got it around the right way and it's sitting correctly in the socket, and make sure the clips close. And the process for installing our 2nd stick is exactly the same. And the process for installing the RAM on our AMD board is exactly the same as the Intel board. Last step before installing the motherboard into the case is to install the brackets for our CPU cooler. I'm going to be showing you how to install an AIO in both the systems. So a high-end AIO that requires software to control it on this one, and a more budget-oriented, easier to set up AIO on this system. If you do want to go with an air cooler, what I would recommend doing is installing the whole air cooler onto the motherboard at this stage. I'm not going to show you this in this video, but what I will do is put a link to another video where I install an air cooler, so you can follow this at this stage, install the whole thing onto the motherboard, and then install your motherboard onto the case. So the big differences between installing the brackets on the motherboard, you'll notice that our Intel system just has holes in the motherboard, whereas our AMD system has these clips, which some CPU coolers will use. So taking a look at the back of our Intel board, we've just got 4 holes. And as we've mentioned, we've got an LGA 1851 socket. And the mounting holes for LGA 1851 are exactly the same as the mounting holes for the older LGA 1700. So when you're looking through your cooler box, you're looking for the backplate for LGA 1700 or LGA 1851. So this is the backplate that comes with our CPU cooler. It will accommodate LGA 1851 and 1700 with the pins pulled all the way into the outer setting. If you've got an older generation, again LGA 1200, you want to have the pins pushed all the way to the middle. So we're going to take the pins and pull them all to their outer setting. And then if we line it up with the holes in the back of the motherboard, the backplate is simply going to slot through. Then we've got one of these spacers to go over each corner. It's just a matter of pushing them down. And that's our Intel motherboard ready to go. So taking a look at the back of our AMD motherboard with an AM5 socket, we've got this backplate which isn't removable. And if we take a look at the front of the motherboard, you'll notice we do have these stock clips attached to the backplate. Now, some CPU coolers will clip directly onto these clips, and that's why they are here. Other CPU coolers don't use them, like the one that we're going to install. So we're going to need to remove the clips. They're each held on with 2 screws. And then with the 4 screws removed, we can simply lift the clips off. So whatever you do, don't lose these clips and screws. If you decide to change your CPU cooler or sell your motherboard, you're going to need these, so the best place to keep these is in the motherboard box. Then you're going to want to grab the bag of standoffs labelled AM4, AM5, and we're going to screw one onto each corner. And that's our AMD board ready to go. So before we can get our motherboard into the case, we're going to have to remove the panels that are going to get in our way during the build. Now I have done a full step-by-step build guide in both the cases I'm going to be showing you today. For this particular build guide, I'm going to be focusing on just the steps we need to take for the build, but if you want to find out all the features that both the cases offer, you can check out those build guides and you'll find links to them in the description. So to remove our tempered glass side panel, we can get our fingers in a little notch at the back and we can simply pop the panel out from the top and lift up and away. And our other side panel is removed in exactly the same way. And our top panel can simply be popped off from the back. To remove the mesh panel on the side, we've got two captive thumb screws at the back which we need to loosen. And once they have been loosened, we're able to pull the panel backwards and lift away. And I'm not going to be removing the front panel. We've already got two fans installed at the front, so there's no need to remove this. So we can see our case accessory box is down at the bottom, held on with a cable tie. So we'll just cut through the cable tie and then we can remove the case accessory box. So I'm going to prepare our Fantex case in exactly the same way. So we've got two captive thumb screws at the back to loosen up our side panel. Then we can pull the panel backwards, tilt out and lift away. And again, the other side panel, we're going to loosen the captive thumb screws at the back and again, pull the panel backwards, lift it out and away. To remove our top mesh panel, you can get your thumb into this notch at the back and pop the panel up. And then it can be lifted backwards and away. This time out we are going to need to remove our front panel. I'll show you why in a minute. So we can simply pop it out from the top and then we've got a dust filter which we just need to pull out and lift away. And the reason we're going to need to remove it is you can see that our three pre-installed case fans have actually plastic protection on them, which we're going to need to remove. And there's also some plastic protection over our rear fan. So our case accessory box is in our hard drive cage at the bottom, so we can loosen this thumb screw to free the hard drive cage up. We then just need to pull the hard drive cage towards us. That's going to free it up. And then we're going to be able to remove the case accessory box. Just before we set the motherboard into the case, we're going to want to check that all our standoffs are in the right place. So for an ATX motherboard, you can see that we've got 3 rows of 3 standoffs, which means they're all perfectly in the right place for an ATX motherboard. You'll notice we do have some additional holes that you can move the standoffs to if you're going for a micro ATX motherboard. So you can see for it, we're going to be able to use the top 6 standoffs to secure it in place, but we're going to need an additional standoff for here and here. So we need to move 2 of the bottom standoffs up to get them into the right place. So it would be into this hole and this hole. What's very important is there is an additional hole here. And if we had a standoff installed into here, what it would be doing is putting pressure on the back of the motherboard here where it can cause a short and damage your motherboard. So what's really important when you're installing your motherboard in the case, you're going to want to make sure all your standoffs are in the right place so it's supporting your motherboard. But importantly, make sure there's no additional standoffs installed in the wrong place where it's going to be putting pressure on the back of your motherboard. So if you do need to move a standoff, you get this standoff insertion and removal tool in the case accessory box. So it's simply going to slot over the top of a standoff. It's got a screw hole in it, so you can get a screwdriver onto it. You can then take the standoff to the hole that you're going to want to move it to and put it in loosely by hand. You can then take the standoff and insertion removal tool, pop it over the top, get your screwdriver on and tighten it up. So you get one of these with both the cases I'm showing you today, but there is lots of cases that don't include them. And if you are going to have to move the standoffs about, you may need to use a pair of pliers. But for the ATX motherboard that we're using, the standoffs are in the correct position out of the box. So we don't need to do this because our motherboard comes with an integrated I/O shield. But if you go with a more budget-oriented motherboard, the I/O shield might not be attached, and you're going to find it separately in the motherboard box. So if you do happen to have a motherboard with a separate I/O shield, you're going to want to install it now because you won't be able to install it after you put the motherboard into the case. So it's just a matter of lining it up with a cutout at the back and then pushing it into place. And what's really important is the back of it is sharp, so make sure you don't cut your fingers. So next we can set the motherboard into the case, line it up with the standoffs at the back. And you'll notice that our middle standoff is slightly elongated, so once it goes through the middle hole, it's going to help hold our motherboard in place. Now I've done this with the case standing upright just to give you guys a better view of things, but what you'd be best doing is setting the case down on its back where you'll find this much easier. We can then secure the motherboard into place using 9 of the screws with a little lip around the outside from the case accessory box. So moving over to our Fantex case, I've looked and all our standoffs are in the correct position, although again we do have additional places to move the standoffs should we need to for a micro ATX motherboard. Now this motherboard has these additional connectors where our connectors from our motherboard are going to be able to pass through to the back. So this is why this case is compatible with a back connector ATX motherboard. You can see where our micro ATX screws are going to go, and there's no additional cutouts at the bottom of the motherboard. So this just supports back connectors with ATX motherboards, but not back connectors with micro ATX motherboards, where you needed an additional row of cutouts here if it was going to do this. So the process for installing our motherboard is exactly the same as our Lian Li case. We're just going to set our motherboard into place, line it up with the standoffs at the back. Again, when the middle standoff goes into the middle hole, it's going to help hold our motherboard in place. But like I've said, make sure you lay the case down its back. This isn't easy to do for somebody starting off. So the only slight difference with this motherboard is we don't have a center hole at the front to screw into. Our center standoff is resting in the middle hole, but there's nowhere to actually screw it in. So we're only going to be able to secure this motherboard with 8 screws with a little lip around the outside. Again, you'll notice I'm using an electric screwdriver during this build. If this is your first build, you're less likely to do harm using a manual screwdriver. Now we've got the screws into place, we can replace our bottom heatsink. There's little magnets which are going to help line it up at the side, and then it's just a matter of lining it up at the clip and locking it into place. Now the other little covers that we removed earlier on, I'm going to leave off for now. And the reason for that is I'm going to want to route the cables coming from our I/O up and through this cutout to the back where you're not going to see them. And if we put the covers on, it's going to block this little channel at the top. So next thing to do is get our case cables connected up. And the case cables are going to allow these ports on the top of the case to work. So we've got 2 USB Type A ports, a single USB Type C port, a combined headphone and microphone jack, and we've got a power button. And at the moment there's lots of cables running from here, but they're not plugged into our motherboard. So we're going to need to plug them into your motherboard to allow all these ports to work. So your HD audio cable, we're going to plug the front panel audio connectors in to allow that headphone and microphone port on the top of the case to work. You tend to find down the bottom left hand side of the motherboard. So we can go ahead and bring our HD audio cable through the cutout at the bottom. We're going to line it up with a header, plug it in with the HD audio text facing up the way. And then we'll just pull all the excess cable through to the back. Next, we've got our front panel connectors. You tend to find these down the bottom right hand side of the motherboard. And you can see one of the trends we're now getting in lots of modern cases is these cables are all organized into one header. So into here, this is where our power button is going to work, but in a lot of other cases, you'll also have a reset button, power LED and hard drive indicator LED all connected up to the one header. We're going to want to plug this into the header down the bottom right hand side of the motherboard. So not all cases it's going to come as a single cable, and in a lot of other cases it will come as separate pins. So I'll show a bit of footage of how you would plug this in if the pins all came separately. So if this is the case, you're going to want to check the diagram in your motherboard manual. So into the top row, into pins 1 and 2 from the left hand side, you're going to plug in power LED positive and power LED negative, and it is important you plug these into the right pins. Next to this, you're going to have your power switch. It doesn't matter which way round it goes, but I generally just plug them in with the text facing down the way. Then moving down to the bottom row, pins 1 and 2 are for hard drive LED positive and hard drive LED negative, and again it's important the positive goes into pin 1 and the negative into pin 2. And then next to this you're going to have your reset switch, and again it doesn't matter which way it goes, but generally I just plug it in with the text facing down the way. Next we've got our USB Type A cable, and we've got 2 headers in this motherboard that we can plug it into. So there's one down the bottom of the motherboard, but we've also got a right angle connector here, which is the one I'm going to plug it into. So you'll notice the connector has a little cutout at the front. So there's going to be a notch on the cable that we're going to plug into this. The key thing with this cable is it's really easy to damage the pins in this header. So don't push it in unless you're sure you've got everything completely lined up. And I have done this in the past, and it means the header is completely useless. So you can see we've got the little notch here. So we're going to line it up with the header. And once we're happy everything's lined up correctly, it's a little bit of firm pressure and it's going to push into place. So as I've mentioned, this is a really high-end motherboard that I've got here. So it's going to have 2 front panel Type C headers. The bottom one's going to support speeds of 10 gigabits per second and the top one 20 gigabits per second. So we've only got one Type C cable because we've one Type C port at the top of the case. So we're going to want to plug it into the 20 gigabit per second port. So we can bring our cable through, we'll line it up with a header, and then we can push it into place. And again, we'll just pull all the excess cable through to the back. So we've got 4 pre-installed case fans in this case. There's 2 at the bottom, which are going to sit beneath our graphics card and bring cooler up and into the graphics card. And Lian Li have already joined the 2 fans together. So we've just got this one 4-pin fan connector coming from the 2 fans. And we've got 3 system fan headers in the middle of the motherboard. So all we need to do is line this cable up with the headers and push it into place. So we've also got 2 fans at the front of the case. And again, Lian Li have joined the 2 fans together, so there's only one set of fan cables to plug into the motherboard. Now the difference with these fans is they are going to have lighting on them, which means there's an extra cable to plug into the motherboard. So again, if we take a look around the back of the case, we've got this 4-pin PWM cable, and this is the cable which is actually going to power the fans, making sure that they spin. And we're going to be able to adjust the speed of the fans using the fan curves in the motherboard BIOS. I'll show you that towards the end of the video. And it's this cable which is going to power the fans, make them spin, and also control their speed. The other cable that we've got is a 3-pin 5V RGB cable, and this is the cable which is actually going to control the lighting effects on the fans. We're going to plug this into your motherboard, and that's going to power the lights, but also allow us to adjust the lighting effects using our motherboard software. And again, I'll show you that at the end of the video. So again, the PWM cable, we can just plug into another fan header at the bottom of the motherboard. And we've also got 2 RGB headers at the bottom of the motherboard. So again, we're just going to have to take care we've got the cable around the right way. So there's 2 pins, a gap, and 1 pin. So you just need to line it up correctly with the motherboard and push into place. So moving over to our back connector build, you can see all the connections passing through to the back of the motherboard. So the big advantage of this, we're not actually going to have to bring the cables through to the front and then pull them back again. And we shouldn't actually see any of these cables from the front of the case. The one thing I'm noticing is we do have this large cutout still over to the right hand side of the motherboard. So we're going to be really careful that we manage all the cables away from this cutout and try and keep them towards this side in the middle. And we've got this cable management bar, which is going to help us manage all the cables at the end. So I'm just going to free up all the cables to start with. Okay, so the cables are generally going to go into the same place as a back connector motherboard, but you're just looking at things reversed. So the bottom left hand side of the motherboard, it's the bottom right as we look, is where we're going to plug in our front panel audio connector. So we take a closer look at this header, you'll notice there's a pin missing in the top row, and also in this cable there's a hole missing. So we're going to need to plug this in with the HD audio text facing up the way. So next we've got our front panel connectors, and again they're going to go into the header down the bottom right hand side of the motherboard. Again, the bottom left is where you're looking because everything is reversed. This is quite a long header, but it's the pins over towards the right hand side as we're looking at it that we're going to want to plug our front panel connectors into. And again, if you look at these, you'll notice there's a pin missing in the bottom row at the end. And again, looking at the cable, there's a hole missing. So because it's the bottom row, we're going to have to install it with the front panel text facing down the way. So then we come onto a USB Type A port, which is going to allow the 2 Type A ports at the top of the case to work. So again, we've got a little notch on the cable, a notch on the header. So just make sure we line it up correctly before we push it into place. And once we're happy, everything's sitting correctly, a little bit of pressure, and it's going to slot into place. Then we've got our front panel Type C header. And again, this is a more budget orientated board, so you've only got one of these and only one Type A port. So we just need to line the Type C cable up and push into place. So then we've got all our case fans, and Fantex have been really kind and connected them all up together. So again, 2 familiar connectors from the last time. We've got a PWM cable, which is going to power all our fans and allow us to adjust the speed of them using our motherboard fan curves. And we've got that familiar 3-pin 5V RGB cable, which is going to power the lighting on the fans and allow us to adjust the lighting effects. So we've got a 3-pin 5V RGB header here. So again, just line the cable up with it and push into place. And then just a little bit above, we've got a system fan header. So we'll take the PWM cable and plug it into here. So this brings us on to our power supply, and the first thing to do is get the right size of power supply. So these are all ATX power supplies, which is the standard one you're going to use in most mid-tower and full-size builds. We've also got an SFX power supply, and this is for mini ITX cases where you don't have enough space to fit one of these larger power supplies. You also get SFXL power supplies, where the power supply is sort of similar form factor at the back here, but is actually a little bit longer than this SFX power supply. So as a general rule, you don't want to use these power supplies unless you have to. So if your case supports an ATX power supply, this is generally what you're going to want to go with, because they tend to be cheaper, they go up to higher wattages, and you've also got bigger fans, so it's going to run cooler and quieter. These you have to use in small form factor builds when you can't fit one of these, and that's the main reason for using them. Next thing to consider is your efficiencies. At 80+ rating, and the power supplies will generally go bronze, gold, platinum and titanium. And as the efficiency rating goes up, there's less wasted energy. More of what you're drawing at the wall is delivered to your PC. The more budget bronze option, you're going to waste a lot more of that energy. It's going to be let out as heat, and your power supply is going to run potentially hotter, and your whole system is potentially going to run hotter, and it's going to cost you more to run your system. But that doesn't mean you should go all the way up for that titanium power supply, because the amount of money you're going to pay to get that, you may not recuperate on your power bills. So there is a sweet spot. One thing I would say to you is do not cheap out on your power supply. If you're going to cheap out in any part in your system, do not do it on your power supply, because it is the part that can set your house, your PC on fire, and you do not want this to happen. So in general, if you really are trying to save money, you can go with a bronze power supply. My advice would be to try to go with a gold power supply if possible. But the most important thing, even more important than the efficiency rating, is get a power supply from a recognized brand. You do not want to find one from a brand that you do not know, because I would not trust that in my house. I would be worried about it setting my house on fire. So always pick a power supply from a recognized brand. If you can, go for one with a gold rating. If you're trying to save money, by all means go with at least a bronze. Another thing to consider is how much power do you actually need. So what I would do is use an online power supply calculator. I tend to use BQuats 1. You're going to put in all the components you've got in your build, and I've done that for both our systems to work out what power supply we need. When you look at the results, you'll see that some of the power supply options are running pretty close to 100%, and these would not be recommended. You want to leave yourself a little bit of headroom, because your power supply doesn't run very efficiently when it's up running towards 100%. The other problem is it generates a lot of heat, your fan's going to kick in, your whole PC is quite noisy. But using this online calculator, it will recommend power supplies for you. So certainly over the last few years, PC components have got much more power hungry, particularly graphics cards. So you might think, should I future-proof my power supply? I'll go for one where the wattage is way more than what I'm going to need, and this will last me for years to come. I certainly think you should go a little bit above what you need to future-proof things for a few years anyway. I would worry about trying to do it for longer than that, because what happens, a lot of the power cables are going to change. We've had the 12-volt high power cables, they've been replaced by 12-volt 2x6 cables. And if you have an older power supply and new cables come out for new graphics cards, you might have to upgrade anyway, although there is some workarounds which we'll come on to talk about. So I would certainly go a little bit above what you need in terms of wattage, but I wouldn't try to future-proof for years to come, because new technology will come out and you probably will have to upgrade your power supply at some point. So what about the ATX standard? Well, the latest standard is ATX 3.1, and if I was picking up a power supply now, that is what I would go for. We had ATX 3.0 come out round about the 40 series card launches, and NVIDIA brought out the new 12-volt high power connector on their graphics card. So we needed the 12-volt high power cables to power that graphics card with a single cable. And that's an example of this cable, which can carry up to 600 watts of power to your graphics card. And all the graphics cards started shipping with these adapters where the standard PCI cables could be plugged in, and you had a 12-volt high power cable if you had an older power supply. So as well as just having the new connector, the graphics cards were really power hungry with high power excursions. So the new power supplies had to be able to handle up to 200% of their maximum rating for these excursions. So with these power hungry graphics cards drawing so much power through a single cable, we had issues where the cables weren't being properly plugged in, and that was setting PCs on fire. And this is where the ATX 3.1 standard came in. They made some modifications to those cables to make them safer, and it is now a 12-volt 2x6 cable with the latest ATX 3.1 standard. So if I was buying a power supply from a new PC, it didn't have one, that would be what I would go out and buy, an ATX 3.1, because it includes that latest standard cable for the latest NVIDIA graphics cards, which is going to be reasonably safe. The ATX 3.0 is probably okay if you're careful, you don't bend the cable close to the graphics card, you make sure it's well plugged in. But again, if you're going out to buy a new power supply, why would you buy the older standard that potentially had some problems? I would pick up the latest ATX 3.1 power supply if possible. So another thing to consider when getting your power supply is, do you want a fully modular power supply? So these power supplies here are fully modular, they come without any of the cables plugged in. Big advantage of these power supplies is you're only going to need to plug the cables in that you need. You can leave all the other cables in the box and they're not going to clutter up the bottom of your PC. This is a semi-modular power supply, so the main cables are directly plugged into the power supply and can't be removed, and you can plug in the additional cables that you're going to need. The cheapest option is a non-modular power supply where basically all the cables are plugged into the power supply and can't be removed. Big advantage of these, they tend to be cheaper. Disadvantage is at the bottom of the case, you've got loads of cables that you're not actually going to need. I definitely do prefer a modular power supply if possible, because I think it certainly just gives you a cleaner build without a whole load of cables at the bottom that you're not going to need. But again, you're going to have to weigh in the price versus the performance, and is this worth it to pay extra for? Color is another important thing to consider. The power supplies do come in black and white, so if you are going with an all-white build, you might want to consider a white power supply. The other thing is look at the cables that come with the power supply. Although this is a semi-modular power supply, it comes with nice black braided cables, so these look quite good. A lot of the cheaper power supplies, they come with multicolor cables, which are going to look absolutely horrible. And like I say, if you're going with a white power supply, check that it comes with nice white cables, because this is going to really improve the aesthetics of your build. And when you're getting up towards those higher end power supplies, you're getting these lovely premium braided cables, lovely metal cable clips, and you'll notice when we put this into our build, it's going to look absolutely stunning. When we're on to cables, make sure that the power supply you're getting has all the connections that you're going to need for your build and the right number of cables. If your motherboard is 2 8-pin EPS cables, but the power supply only comes with 1, are you going to be happy with that, or should you have actually done a bit more research and made sure the power supply was going to meet your demands before you bought it? Another thing you're going to want to check is the length of your power supply and make sure that your case will accommodate it. Most cases will, in their specifications, list the maximum length of power supply you're going to be able to fit in it, and remember to factor in your cables as well. So if you have got a power supply that doesn't have the nicest cables, another option you have is to get some cable extensions. So this is a 24-pin cable extension. We can take the cable coming from this power supply and plug it into it. So the bits that are going to be at the front of the case are going to be these nice black and white cables, and we're not going to see this bit at the back of the case. So it's a really nice way to improve the aesthetics of your build. Downside of this is you have massively increased the amount of cables at the back of the case, and cable management can be quite difficult, and you might struggle to get your side panel back on again depending on the case that you've gone for. So again, these are going to cost you extra money, extra headache with cable management, but is it actually going to be worth it in terms of the aesthetics? What I do like to do is make sure that we've got nice cables. So the black power supply from Fantex that I'm using comes with lovely black braided cables, and this white power supply from Thermaltake has lovely white cables. So again, I'm not going to need to look down the cable extension route. And a set of cable extensions will maybe cost you anywhere from 30 to 60 pounds, depending on the type that you're going for. So just by spending a bit of time, making sure you've got nice cables with your power supply, you can save yourself a bit of a headache and a bit of money. Okay, first thing to do is get the cables plugged into our power supply that we're going to need. And you'll notice when we look at the connectors in the back of the power supply, they are labeled. So the first cable that I'm going to plug in is our 24-pin motherboard cable, and it comes in 2 parts. There we go. And when you plug it in, you get a nice click as it goes in. So on the other end of the power supply, we've got this cable, which is the main power supply to our motherboard. You'll notice then that we have got 3 ports labeled CPU and PCIe. So the next cable we're going to plug in is our EPS cable to provide additional power to our CPU. So if we take a look at the other end of the cable, we've got 2 8-pin connectors labeled CPU. And this EPS cable provides additional power to our CPU, and these are normally plugged into the top left of the motherboard. So we've got an 8-pin connector and an 8-pin connector, and some motherboards will have 1 8-pin connector, others will have an 8 plus a 4-pin, and other high-powered motherboards will have 2 8-pin connectors. So this one cable will power most motherboards. If you do have a 4-pin connector, the cable simply splits in 2. I just slide it here, and then you're going to be able to plug one of the 4-pin connectors in. If you don't need the additional 4-pin connector, you can just leave it at the back of the case. There's other power supplies where you'll have 2 separate cables to plug in. So if you've only got one 8-pin connector, you just need to plug 1 cable in. So you'll notice we do have 2 connectors here that we could plug a standard PCIe cable into. And this is your standard PCIe cable. And on the end of it, we've got a 6 plus a 2-pin connector, giving us an 8-pin connector. So this 8-pin connector isn't the same as the one we're going to plug into our CPU. This PCIe cable is designed to be plugged into graphics cards. You'll notice as well that we have an additional 6 plus 2-pin connector on it. So we are able to actually fill 2 8-pin connectors on a graphics card with a single cable. My advice is if your graphics card has 2 8-pin connectors, I wouldn't use the daisy chain connector here. I would plug 2 separate cables in, because then there's going to be less power going through the cable and it's less likely to cause issues. If our graphics card had 3 8-pin connectors, then we'd have no choice in this power supply but to use one of the daisy chain connectors and use one connector on a second cable. But because we're using one of NVIDIA's new graphics cards with a 12V 2x6 connector, we're not going to use the standard PCIe cables. So because we've got the latest ATX 3.1 power supply, the connector is labelled 12V 2x6, which is the one that has the improvements made to make it less likely for your PC to go on fire. And if we take a look at our cable, it's rated for 450 watts of power to the graphics card. There is other power supplies where the cable is rated for up to 600 watts. So we're just going to take our cable, line it up with a connector, and push into place. And this is the really important step. You're going to want to really make sure this cable is pushed all the way in and you get a nice audible click. I'll just show you a 12V 2x6 cable from another brand. What they have done here is they have the pins all a nice bright colour. So if you haven't plugged it in correctly, you'll see the blue colour and realise that you haven't done it. And if it's pushed in all the way, the blue colour will disappear. And again, there's a similar for the graphics card, because it's just as important that you plug the cable fully into your graphics card as well. So you'll see the other cables are labelled peripheral and SATA. We've got 3 ports, so I'm going to plug a SATA cable into one of these. And if we take a look at the cable, you can see that we have got 4 SATA power connectors on it. And we're going to be able to power, for example, fan hubs. Some cases will need a SATA power connector to power an RGB hub, or we can actually power a SATA drive. Now, I've mentioned I wouldn't generally use SATA drives, but some of you may want to do it, so I am going to show you how to install a SATA drive in one of the builds, which is the reason I'm plugging this cable in. If you're not planning on installing a SATA drive, you can leave this cable unplugged. So this power supply features a smart zero fan mode. So whenever the power supply is under low load, the fan in the power supply will stop spinning, helping reduce noise in the build. So I think that's a good idea. So I'm going to go ahead and turn this to on. So this is our power supply's intake fan. So it draws cool air in from here. So what's important is that in general, for most cases, you're going to want to have this facing down towards the underside of the case. There's generally a dust filter here to get you cool filtered air into your power supply. Although the orientation may change. If you don't have a vented area at the bottom of the case, you may want to install the power supply a different way round. And this is the bit that's going to be facing out the back of the case, and this is generally where all the hot air coming from the power supply is exhausted out. So we can go ahead and set our power supply into the bottom of the case, making sure the power supply's intake fan is facing down the way. And we'll slide it all the way to the back. Then we can secure the power supply into place using 4 of the large power supply screws from the case accessory box. This is our EPS power connector, which provides additional power to our CPU. This motherboard has only one 8-pin connector. So if your motherboard does have more than one 8-pin connector, you still only need to plug in one 8-pin connector to get your PC to run. The additional connector is for supplemental power to a really high-powered CPU, particularly if you overclock it. But in general, one 8-pin connector will be enough power for most CPUs to run. My advice, however, is if your power supply is the additional cables, and you have an additional connector, plug it in. If you've got a power supply that doesn't have the additional cable, you're probably going to be okay with one 8-pin connector. Although if you do have a high-powered CPU, something like a 14900K, and particularly if you're going to overclock it, 2 cables would probably be ideal. So all we need to do is line our connector up with the power supply and push it into place. And you'll notice we've just got one spare 8-pin connector, which we're just going to have to manage at the back of the case. So a 24-pin connector tends to run on the right-hand side of the motherboard. If we look at one side of the connector, you've got this little catch here, and we've got this little clip on the cable. So the clip is going to go over this catch and hold it in place. So if you're trying to work out what way to insert it, that's how you know. And then we can simply push the cable into place, and we've got a nice click here showing that it's fully secured. So I'm going to be using this 1000 watt platinum power supply for our Intel build, and you can see our graphics card connection is labeled 12 volt high power, and that's because it is an ATX 3.0 power supply. The reason I'm using it is the cables are absolutely gorgeous, and you'll see this when we complete the build. So we're going to start off with a 12 volt high power cable. We'll line it up with the power supply and push it into place, and again making sure we get a nice click, particularly given this is an ATX 3.0 power supply. So we've got 5 connectors here labeled PCIe and CPU, so we can either plug a PCIe cable or an EPS cable. So our motherboard needs 2 8-pin EPS cables. We do have a Core Ultra 9 processor, and I'm definitely going to want to plug both of those in. So we'll go ahead and plug one of them in, and you'll notice on the other end of the cable we've got a single 8-pin EPS power connector. So that means we're going to have to plug 2 separate cables in. So we'll plug our second cable into here. So the particular motherboard that we're using has a supplemental PCIe power cable. We do have spare connectors and spare cables in the box, so I'm going to go ahead and plug it in. If you've got a different motherboard that doesn't have this connector, there's no need to plug this cable in. So you can see we've got 5 ports here for SATA and Molex cables, and then our 24-pin cable is going to go in these headers at the top. So similar to our other power supply, this power supply also has a hybrid fan mode. Again, when the power supply is under low load, the fan stops spinning. It's not quite as easy to understand what way you need to have this switch. There's no on or off. So when the switch is in the in position, the hybrid fan mode is turned off and the power supply's fan will run all the time. So what you need to do is bring the switch to the outer position to turn the hybrid fan mode on, meaning under low loads, the fan will stop spinning and help reduce noise in the build. So the location of the power supply in this case is a little bit unusual because it's going to go on its side at the front, but this is one of Leandy's main selling points about this case. So normally your power supply would go at the back of the case. The downside about that is it's going to block airflow into your graphics card. So by moving it to the front, we're going to be able to pull plenty of cool air in from both sides of the case with these fans and straight into the graphics card without the power supply obstructing its flow. And you'll notice that all the intake at the front is going to be above our power supply, so it's not going to interfere with intake at the front either. So because our power supply is at a little bit of an unusual location, we're going to use this cable extension to plug into our power supply, and the end of the cable goes to this connector at the back of the case. So you're still going to be able to plug your wall cable for your power supply directly into the back of the case. So the first thing we're going to need to do is just free up this cable with the cable tie, and then we're going to be able to slide our power supply into place at the bottom, making sure we've got our intake fan facing the bottom of the case. Now it can be a little bit difficult to get the power supply into here. You just have to move the cables out of the way. And then we'll secure the power supply into place using 4 of the large power supply screws. Now, a very important step, once we put our side panel on, we're not going to have access to our power supply's power button, so we're going to want to make sure this is turned to on. And then we can go ahead and plug in our cable extension. And we'll just tuck it in out of the way, and there is a little notch here that helps hold it in place. And then we can replace the side mesh panel. So you can see the other reason that Leandy have done this, but having your power supply on the side means you've got easy access to all the ports should you want to add additional cables in or change something out. Whereas if you have a more traditional power supply orientation, you're having to look in from the side. You can't really see what the labels are, particularly if there's one cable in the way. It makes it more awkward to get in at this cable. So we've got our 2 8-pin EPS cables at the top left of the motherboard. So we'll go ahead and bring our cables through the cutout and get them plugged in. And then we'll just do the same with our second connector. And again, you're just going to want to get the cable combs to line up on both cables. So you can see we've got our 24-pin cable here, and then we've got our supplemental PCIe connector just below it. In terms of what this supplemental PCIe connector does, for this particular motherboard, it just improves the speed of the fast charging for our Type-C port. So it is completely optional. If you don't plug it in, you're still going to get fast charging, but not quite as fast. There is other motherboards I've checked out recently, a couple of MSI boards where they have this connector down at the bottom of the motherboard, and what it does is provide additional power to your graphics card, making sure it won't run out of power during the power excursions. So it is worth checking the manual if you do have one of these extra connectors, and then you can decide whether you want to plug the cable into it or not. So I'm going to go ahead and bring our PCIe cable through the cutout. We'll just try and line the 6-pin up with the 2-pin, and then we'll line it up with the header and push into place. And again, we'll pull the excess cable all the way through to the back, and we'll use our cable combs to just help tidy up the cables. The other option that we would have is to bring the cable through this rubber grommet. I think it's going to look better through this cutout. And then we can bring our 24-pin cable through and get it plugged in. And again, we're just going to pull all the excess cable through to the back, and we'll use our cable combs to help tidy the cables up. So next thing to take a look at is cooling our CPU, and the first question to address is, should we go with an air cooler or should we go with an AIO? And both have their pros and cons. Air coolers generally have fewer parts, fewer things that can go wrong. Certainly there's no water in it, so you're not going to end up with water all over your system. There's no pump to fail, so you're less likely to get a failure with an air cooler than you are with an AIO. Also, air coolers tend to be cheaper than you pay for the equivalent AIO, although you can get really premium air coolers which will be more expensive than a cheaper AIO. Downsides of the air coolers, and these are subjective, particularly if you go with one of the larger, more premium air coolers, they are going to block up a lot of your build. You're not going to see the expensive motherboard that you paid for, whereas if you go with an AIO, you're going to get a nice view of all your hardware. And the final thing is the cooling potential. So certainly a premium air cooler like I've got here, it will exceed the cooling capacity of a 240mm IO, but I would expect a good 360mm IO to cool better than this premium air cooler. So if you really have a hot and difficult to cool CPU, you're going to cool it better with a 360mm IO. One of the nice things with the latest generation of both Intel and AMD CPUs is they're becoming more power efficient, so they are easier to cool. The previous generation, the 14900K, was absolutely impossible to cool even with a 360mm IO. I was recording it under load with temperatures well over 100 degrees. The new generations of CPUs were getting up to 80 at the max for most of the tests that I'm doing with them. So you're going to get away with less cooling with the latest hardware. So you did want to go with air cooling. There is a number of budget options. I'll put links in the description that are Ryzen 7 9700X you'd certainly get away with. Our Core Ultra 9 285K, I wouldn't go with one of these more budget options. It would struggle, but a premium air cooler would do an absolutely super job of cooling it. And like I say, you'll find links to suitable air coolers in the description, as well as installation guides for the air cooler. So if you do want to go down that route, you're going to be able to follow along and do that. What I'm going to be showing you today is how to install two different AIOs. And there's a massive difference in price of the AIOs. This one over here is probably about 4 times the price of this AIO. So I want to show you a few differences in what you get for your extra money. Big thing with this one is you're getting a really nice screen that you can do an awful lot with. You can display videos, pictures, and a lot of system information on it. This does have advantages, and that is that there's no software required to run it. So there's not going to be anything running in the background and potentially slowing your PC down. The reason I've gone for this one from Asus, because we're going to be using an Asus motherboard and Asus graphics card, we're going to be needing to use Asus's software to control the RGB. So the same software package will let us customize the display on this, and that's the reason I've gone for the same brand. What I didn't want to do was pick a cooler with another brand, but we're going to have additional software to control the screen on it. And then you've got lots of packages running in the background, potentially slowing your PC down. So you'll see a theme here. It's generally good to look at a couple of brands and try to plan things so you've got the minimum amount of software running in the background. If you do want to go with no software, there is options out there, and this is why I'm showing you these particular options. If you want to know if you're going to need to use software to control the cooler, it is worth taking a look in the instruction manual. If you see anywhere you're going to have to plug a USB 2.0 cable into your motherboard, if you see a screen on the device, they're all signs that you're going to need to use software to control the device. This is simple PWM connectors and ARGB connectors, so there's going to be just our standard motherboard software used to control them. So I want to give you a quick run through how the AIO is going to work. So you'll see here we've got a cold plate, and it's going to make contact with our CPU, and we've got some thermal paste pre-applied. So we're going to fix this to our CPU, and in here we've got a pump. So it's going to pump water down the tubes to the radiator, and then we're going to put fans onto the radiator, which are going to blow cool air through the radiator, cooling the hot water coming from the pump down, and then the cool water is going to go back again, and we've got this circular loop helping cool our CPU down. So there is a few important rules when it comes to mounting your AIO. In general, you do not want the pump to be the highest point of the system. So what we could have here, if we decided we were going to mount this at the bottom of our case and mount this here, the pump would be the highest point. The problem with this is you're going to get some air building up in the system over time. The air collects at the highest point, which would be up at the pump, and that's going to damage the pump, and the pump is going to fail. So that's a bad idea. The simplest thing is to mount your AIO at the top of the case. So in this orientation, any air that forms in the system is going to stay in the radiator at the top, well away from the pump where it's not going to damage it. Sometimes you will want to mount the AIO at the front of the case on its side rather than at the top of the case. And again, this should be okay, provided the pump is not the highest point of the loop. If you can, it probably makes sense to try and mount it with the tubes in the downward position, because again, this means that any air that is going to get into the system is going to get stuck at the top of the radiator, and it's not going to get pushed around the system. There's nothing wrong, it's not going to damage your pump if you do want to mount it in the tubes up position. The only issue you're going to get is that air is going to collect up at this top bit of the system where the tubes are coming in. So there is going to potentially be a bit of turbulence and a bit of extra noise with that air moving about. Downside of mounting tubes at the bottom is it doesn't look great, and sometimes the tubes are going to get in the way of your graphics card. So you're going to have to weigh everything up, but the most important thing is that your pump must not be the highest point of the system, and the easiest thing is just to have your AIO at the top if possible to avoid any issues. Next thing to consider is, should you have your AIO set to intake or exhaust? And really it depends where you're installing it in the system. So we're going to have our AIO at the top of the case. Generally, you're going to have cooler air coming in from the front. Some cases will have cooler air coming in from the bottom. So you're going to want to have that air going through the radiator and coming out the top of the case. And you're going to do that, then you're going to have the fans installed in the correct orientation, where they're going to be pushing air through the radiator and out the top of the case. So if you're going to be having your AIO at the front of the case, I would recommend having it set to intake. So you're going to want to install the fans on this side, assuming this is the front of the case. They'll be blowing cooler from outside the case through the radiator and into the case. The reason you don't want to have it set to exhaust is you would have the ugly side of the fans at the front of the case, so it's not going to look particularly good. And the last thing you want is lots of hot air blowing out through the front of the case into your face. It's not going to be particularly pleasant sitting beside that PC. There is some fish tank cases where you can mount your AIO on the side of the case, and in that particular orientation you have a choice between intake or exhaust, and there's pros and cons to doing both. If you have it set to intake on the side, the downside is you're not going to have the nicest side of the fans on display, so it's not going to look quite as good. Your CPU cooling will be much better, because in this orientation it's going to be pulling the cooler in from the side of the case and through the fans and bringing that into the case. So you're going to be bringing cooler air from outside the case through the radiator, which is going to be better cooling potential than bringing slightly warmed up air from inside the case through the radiator. Downside of that is you're going to be dumping a whole lot of hot air into the case, so it's going to heat up all your other components and your graphics card. If you have the AIO on the side of the case set to exhaust, again, the cooling potential is not going to be quite as good, because you're going to be moving slightly warmed air up through the radiator, but the big advantage is all the hot air from the AIO is going to be going out of the case, where it's not going to heat up your graphics card and other components. So another factor to consider in the case is, if your case comes with lots of pre-installed case fans, where is actually free on your case? So for both our cases, we have fans at the front, one has fans at the bottom, and both cases have free space at the top of the case. So for us in our particular build, it makes complete sense to install this at the top of the case. It's set to exhaust. So if you are a first-time builder, this is where I would recommend you install your AIO, because you're least likely to get into trouble. But as I've mentioned, the new generation of CPUs are just so much easier to cool, so save yourself the headache, put your AIO at the top of the case, set to exhaust, and this is exactly what I'm going to be showing you how to do today. So the final thing to consider is the size of the AIO that you want to install. So it'll come in 1, 2, or 3 fan variants. If they're 120mm fans, they're going to be 120, 240, and 360, and this is a 360. If they're 140mm fans, you're going to get 140, 280, and 420. So just check in the case that you're using the maximum that you're going to be able to fit. In our cases, it's 360 at the top. And again, I think filling the space looks much better. If you go with a 240 and have it in the middle, it looks a little bit out of place. So in terms of aesthetics and the best cooling, I generally tend to try and fill the radiator slot as much as possible. Okay, first step in installing our ASUS AIO is to connect our 3 fans together. And you'll see we've got contacts. There's male connectors here and female connectors here, and the fans are going to connect magnetically. So all we need to do is bring them into contact with each other, and they're going to snap into place, and that's our 3 fans joined together. So if we look at the end of the fans, you'll notice on one side we've got female connectors, on the other side we've got male connectors, and there's 2 different cables, so you're able to have the fan cables coming out whatever side you want. So I have sized things up in the case, so I want our connector coming out towards the back of the case where you're not going to be able to see it. So it's the female end that I'm going to be attaching, which means that I need to use the male fan cable. So again, it's just going to attach magnetically. We just need to bring it up into place, and it's going to snap into place. So coming from the fans, we've got 2 different cables. The first is a 4-pin PWM connector, and we're going to plug that into our CPU fan header, which is going to allow us to adjust the speed of the fans depending on what our CPU temperature is. The other cable is the 3-pin 5V RGB cable, and that's going to let us control the lighting using our motherboard software. So we can go ahead and set our fans onto the radiator, and then we're going to secure the fans to the radiator using the long radiator screws. So it's good practice to not put the screws in tightly at the start, so you're going to just get them all in and put them in slightly loose. And now that we've got all the screws to catch, we can go ahead and tighten them up. So we take a look at the cables coming from our pump. We've got this 4-pin PWM cable, and this is going to power our pump and allow us to adjust the pump speed. And we've also got this USB cable, and this is going to allow us to use the RGB software to control what comes up on this screen. Now the screen is magnetically attached to the pump, so we can go ahead and just lift it up, and it's going to come off, and that's going to simplify the installation process. If you are getting the IO from new, there will be some thermal paste pre-applied to the cold plate. I've used this one before, which is why there's none there, so you are just going to have to take care that you don't damage the thermal paste that's been pre-applied. Next thing for us to do is adjust the position of the bracket. So it can either go up or down depending on the socket that you're installing it in. So for AMD, LGA 1700, LGA 1200, you're going to want to have 2 notches shown at the top and the bracket pushed all the way up. For LGA 1851, which is what we're going to be installing on, so we'll give the bracket a push down. We've only got 1 notch at the top, and that's the correct position for our socket. And then we're going to have to adjust the position of these thumb screws. So for LGA 1200 and AMD, you're going to have them pushed towards the CPU cooler. Whereas for LGA 1700 and 1851, as I said, we've got 1851, we're going to want to have them all pulled to their outer setting. So we're just going to check that they're all pulled to the outer setting. And that should now line up with the bracket we've installed on the motherboard. Just before we set our IO into the case, I'm going to have the tubes facing towards the front, which means they're not going to obstruct the rear fan mounting slot if we wanted to add a fan there. If you installed it this way round, the tubes are potentially going to be blocking the rear fan. The other thing to note is this is a really compact case, so once we put our radiator up at the top, we're going to lose access to these fan headers at the top of the motherboard. So what I'm going to do is pass our fan cables through to the back first of all. We'll just set the IO in loosely at the bottom of the case. So I'm just going to identify the fan headers that we're going to need. So our CPU fan header is this one towards the left, and we've got an RGB cable here. Now I'm identifying which one is our IO pump cable. It's going to be this one third in from the left, because we're going to have to plug in the pump cable into here once we've installed the radiator, and it's not going to be the easiest. So I'm just going to bring our PWM cable through this cutout, and we're going to plug it into our CPU fan header. And the ARGB cable I'm going to bring in through this cutout here and get it plugged into the ARGB header. So next I'm just going to bring our IO up towards the top of the case. And as we do, I'm just going to pull the cable through to the back. And then we can screw the IO into the place at the top of the case using the short radiator screws that came with the IO. And then at this stage we can replace our top panel. So if I size the IO up, and this is going to be the bottom, and we've got this PWM cable coming out the bottom, it's going to look untidy if we just wrap it up around the side. So I'm going to route it up around this bracket here, and we'll come in through here. And that means that the cable is going to be held up nicely with the bracket. I'm also just going to route the USB cable up around this top cutout. So whenever we put the screen back on, it's going to be nicely organized. So I'm going to add some thermal paste to the center of the CPU. If you're using the cooler from new, it's going to be pre-applied to the cold plate, so you're not going to need to do this. Then we just need to line the CPU cooler up with the bracket beneath. And once we're happy everything's lined up, we're just going to tighten each of the thumb screws up in turn. So I always use a manual screwdriver for this because you want to get the feeling, you don't want to over tighten. So we're just going to get each one to catch first of all. Now that each side's caught, we're just going to tighten each corner up a couple of turns before moving to the opposite corner. So there we go, they've all gone tight. So next we've got the difficult task of plugging this PWM cable into our pump header at the top of the motherboard, which is why we identified it earlier on as the third one across. So space is a little bit tight, but just take your time and make sure you get it plugged into the right slot. So that was definitely not the easiest to get plugged in. It is going to take you a bit of time. And you're going to want to double check that you've definitely got it plugged into the right 4 pins, which we have done. So I'm just going to pull the excess cable through to the back of the case. So I'm also going to pass our USB cable through to the back. And just before we return our screen, you can see we've got this nice fan, which is going to help cool our VRM. So we can return our screen, it's going to attach magnetically. And then I'm just going to pull all the excess USB cable up to the top. And if you look closely, you'll see why I've wrapped our cables this way. They're actually completely invisible now. They're hidden behind the bracket, and there's only a tiny bit showing at the top. And we've got 2 USB 2.0 headers down at the bottom of the motherboard. If you look closely at the headers, you'll notice there's a pin missing in the bottom row. And again, if you look closely at the cable, you'll notice there's a hole missing, so we're going to have to install it the right way round. So we'll go ahead and get it plugged into one of the headers. And again, if you are installing the IO from you, there'll be some plastic protection over the screen, which you can remove at this stage. So the three Fantex fans for IO come already joined together, and you'll see that we have a good side of the fans, which we're going to want to face in the front of our case. And we've got a side with the wires connecting the fans together, and we're going to want to have this hidden at the back. So I've lined our IO up in the case. This is going to be the back, so we're going to install it this way round. So again, we're going to use the long radiator screws to secure the fans to the radiator. Then we've got some plastic covers to hide the fan screws. They simply just push into place once you've got them lined up correctly. And then we can remove the plastic protection from the fans. If we take a look at the end of the fans, we've got this male connector here, and we're going to plug it into this cable that comes in the box with the IO. And I'm going to talk you through the wiring while we've got everything on the table, because it's much easier. So the cable that comes from our fans, we're going to plug it into this connector coming from our pump. And then we've got the single connector that would plug into a Fantex hub if you want to go down that route. We're not, we're just going to simply use our motherboard control. So we're going to take this cable that comes with the IO and plug it into it. So coming from the end of this cable, we've got a 4-pin PWM connector, and that's going to go into our CPU fan header, allowing us to control the speed of the fans on the radiator. We've also got a 3-pin 5-volt RGB connector, and we should be getting quite familiar with these now. So that's going to let us control the lighting on the pump itself and also the lighting on the fans. The other cable coming from our pump is this 3-pin fan connector. Although it's only got 3 pins, we're still going to be able to plug it into the 4-pin pump header on our motherboard. You'll notice there's little notches on the cable, so it's only going to go into the right 3 pins. The one difference with what we have to do with this pump, because it's only got 3 pins, we're going to have to make sure when we set up the motherboard BIOS that we run this fan in DC mode. To run it in PWM mode, pulse width modulation, we need this additional 4th pin, which we don't have here. And if we were to run this in PWM mode, it would run at 100% all the time because we're missing the 4th pin. We take a look at our pump, we've got some plastic protection and we've got some thermal paste pre-applied, so we're not going to need to add any additional thermal paste. At the moment, we've got the Intel bracket on, but because we're going to be doing an AMD installation, we need to remove the Intel bracket. So it's just a simple matter of pushing this bracket up the way, and that is going to remove it. We're then able to slide our AMD bracket into place and push it down to lock it into place. So again, just before we set our IO into place, I'm going to pass the fan cable through the cutout at the top to the back of the case, and then we can set our IO into place at the top. We can secure the radiator at the top using the short radiator screws. And then at this stage we can replace our top panel. So I'm just sizing the pump up. This time our cables are going to be coming out directly to where we want to bring them up, so there's no need to wrap them around the bracket. So we can go ahead and remove the plastic protection, and then we just need to line the CPU cooler up with the bracket on the motherboard. We'll just hold it in place, and we've got a thumb screw to go onto each corner. Then all we need to do is tighten each corner up in turn. Next, we're just going to need to pass all the cables through to the back. And now that the cables are through, we can place the magnetic motherboard covers. Then at the back, we've just a few cables to connect up. So we're going to connect the cable coming from our fans into the cable coming from the pump. And then we'll just plug in that adapter. So we've got 3 fan headers at the top. Our CPU fan header is the one in the middle. So we'll plug the 4-pin cable into it. Next to it is our CPU opt header, so I'm going to bring the 3-pin cable coming from the fans on the pump through, and we'll get it plugged into it. You'll notice it can only go into the right 3 pins with a little bit of plastic at the top, and we're going to have a spare pin over to the left of the header. And we've got another RGB header down at the bottom of the motherboard, so we'll plug the RGB cable into it. So I did say I would show you how to install a SATA drive, so we'll remove our hard drive cage. It's held on with this captive thumb screw. And then once it's been removed, we can pull the drive cage towards us and remove it from the case. So in the top of this drive cage, it is possible to mount 2 2.5-inch drives. So we can have one here and one here. Or if you do want to go with one on the top, it is possible to mount one round this way here. If you prefer, it is possible to mount a 3.5-inch drive on top of the drive cage. And in the drive cage itself, it is possible to mount a 3.5-inch drive. So we'll just set it into place. And you'll see if that's the option you're going for, you're going to secure it with 3 screws at each side. So before we install the drive, I just want to show you the connectors that we're going to get at the bottom. So we've got a SATA power connector and a SATA data connector. So we're going to plug a cable from our power supply into the power connector to power the drive, and the data connector, we're going to plug a cable that comes with our motherboard into it and the other end into a SATA port on our motherboard. I would take a look in from the end, you'll see that both of these connectors have L-shaped connectors on them. Okay, so we'll set our drive on top of the hard drive cage, and we'll secure it into place using the same screws we used to secure the motherboard to the case. Then we can plug the cables in. I'll show you this out of the case because it'll be a bit easier to get a good view of it. So we can plug our SATA data cable into here, and there's a little locking connector, so when we need to remove it, we need to push this little bit of metal down to allow us to remove it. And then we can take our SATA power connector, line it up and push it into place. Then we can return the hard drive cage to the case. We've got 4 SATA connectors on the back of the motherboard, so we'll just line the cable up with one of these and push into place. So you can see why I'm recommending going with NVMe drives, because not only are they going to be faster at a similar price, but they're so much easier to install and you're not going to have these additional cables running at the back. Okay, next thing to chat about is fans, and fans over the last few years have got really advanced and really complicated, which is why I'm probably going to spend quite a bit of time here. So the reason I picked the cases that I've gone with is you don't need to do anything additional to them. They're already plugged into the motherboard. We're going to do a bit of customization of the fan curves later on, and I'll show you that. But there's nothing extra to add in or nothing complicated to think about in terms of the airflow. What I will do is spend quite a bit of time talking through how the fans work, how the airflow in the case works should you want to deviate away from things, but if you're happy with the build as it is, just skip to the next section. So I'm going to start off with some older fans because that's going to make things a little bit easier to understand. You're going to see the problems and then you'll understand why fans have evolved the way they have over the last few years. So this is a non-ARGB fan. Because it's non-ARGB, it's just got one cable coming from it, and it's got a 4-pin connector on it, which means we're going to be able to run this in PWM mode. So PWM stands for pulse width modulation. So how that works is we apply 12 volts to the fan all the time. We're not adjusting the voltage, but we've got an extra pin compared to a standard 3-pin fan connector. And what that extra pin is controlling is the on and off signal. So it's how long does that 12 volts being applied to the fan. If we get the full 12 volts, the fan runs at full speed all the time. If it gets no volts, it doesn't spin. And obviously the longer that signal is turned on, the faster the fan will spin. So there's very quick pulses, so it's on, off, on, off, on, off, and the longer it's left on for, the faster the fan spins. So that's a really nice way to control the fan. You don't have to do that, you can control it using voltage. So in the voltage curve, you're able to pick the voltage you want applied to the fan. And depending on how much you turn the voltage up, the faster the fan will spin. The less voltage, the slower it will spin. The downside of using voltage is the minimum speed of the fans is much higher with voltage control compared to PWM. And that's why people prefer the 4-pin connectors in PWM, because you can get the fans running nice and quiet at idle when you don't need them running faster. The standard 3-pin connectors using voltage control, you're going to have to run them much faster than what you need to at idle. So for that reason, I always recommend 4-pin connectors, running them in PWM mode, because you're going to reduce the idle noise in your build. And in general, if a case manufacturer includes 3-pin connectors in it, I'm going to criticize it in the review, because it only costs a tiny amount of extra money to get the 4-pin connector, and it's going to significantly reduce the idle noise in your build. If you do have 3-pin connectors, for example, the pump on the I/O that we installed has a 3-pin fan connector. What is really important is that we must run that in voltage mode, DC mode, in the motherboard BIOS. If we leave it at PWM mode, what we will do is apply 12 volts to that fan all the time. It will be missing the extra pin that the motherboard will be sending the on-off signal to, so it will never be turned off. So it will get 12 volts all the time and run at full speed. So if you have a 3-pin fan connector, it's really important that you run it in DC mode or voltage mode in the motherboard BIOS. So a lot of motherboards will detect whether you've got a 3 or a 4-pin connector in, and they'll use the auto detect mode to enable the right fan curve, either PWM or DC mode. But you can just confirm that they are running at the right speed when you go into the motherboard BIOS. And if you turn your PC on, it's got lots of 3-pin connectors and they're all running at 100%, the chances are you're running PWM mode in the BIOS. And if you switch them to voltage control, the idle noise is going to come down significantly. Okay, so that's your standard fans, no RGB, one cable, fairly simple to install and fairly simple to control. So over here we've got a standard ARGB fan. So you can see we've got still the power connector, and this is a 4-pin PWM connector here. But you'll notice we've got a daisy chainable connector here, so we can plug the PWM connector from the next fan into here, meaning we have just one connector to plug into our motherboard. The other connector coming from it is a 3-pin 5V ARGB connector, and that is going to give us addressable RGB. So it means we're going to be able to display lots of different colors on the fan at once rather than having to go with a static color. You probably noticed in some of the motherboards you've also got a 4-pin 12V non-addressable header. These were older connectors, and again I don't have any of these fans left to show you, but you can only display one color at a time on those fans, and they have generally been replaced with ARGB connectors. Again, ARGB headers on the motherboard are limited, similar to your PWM headers, so a lot of fans will have an additional daisy chainable connector, so you can take the connector from the next fan, just line them up and plug them in, and that means you're going to be able to use one header on the motherboard to power multiple fans in terms of the lighting and adjust them using your motherboard software, and again with PWM. So as a general rule, if you are daisy chaining fans into your motherboard header, I don't like to do any more than 3 into any one header. You can go in and look at the voltage available in the headers and see can you push things a little bit harder, but in general 3 fans to any one header is a simple rule to remember. So if you don't have enough headers in your motherboard and your fans don't have these daisy chainable connectors, what you can get is a fan splitter cable. So this is a PWM splitter cable. It's got 3 ports in it, and what you would then be able to do is take your fan connector and plug it into the cable, and then plug the other end into the motherboard, allowing you to plug 3 fans into any one header. So this doesn't need additional power because the fans are powered directly from the motherboard header, but it's important that you don't overload it. And that's why generally these come up to 3 fans in one go. You're not going to find these with 5 or 6 fans plugging into that motherboard header. If you do want to plug more than that into any one header, what you will get is a fan hub. Quite often you'll get these up to 10 ports, but they will need additional power because they can't take all that power from that motherboard header. And in general, you'll find a SATA connector coming from them. You're going to need to plug that SATA connector into your power supply to power the hub, and the PWM cable go into your motherboard. All that does is send the signal from the motherboard telling the fans what speed to run at. Similarly with the ARGB, you can get the ARGB splitter cables. So you're going to be able to plug multiple ARGB devices into one header. Again, if you want to have loads of ARGB devices been controlled in one device, it tends to be what we call a hub, and that hub is going to need additional power, and the ARGB cable going to the motherboard, all it's doing is bringing the ARGB signal to the hub. It's being powered by SATA, and then that's then controlling all the devices, because if you have too many devices, it's not going to be able to draw all that power from the ARGB header. So one of the downsides of bringing ARGB into the build is you're going to have to use some sort of software to control it, and in general that's going to be your motherboard's ARGB package. Some people don't like doing that because then again you're going to have software running in the background when your PC is running and it can use some resources. So an alternative is to get an ARGB controller. So this is a fairly basic ARGB controller. You're going to plug your ARGB device into here. There's a little button that you can press to cycle through the ARGB effects. It's going to need power, which is SATA power, and this means then you're not going to have to use your motherboard software, but you're going to be able to have ARGB in your build if you want. So the other important thing to address is the direction of airflow through the fans, and previously this was very easy to determine. You had a good side of the fans with potentially some writing on it, you could see the fan blades. You had the back of the fans where you had the text and you had something blocking the blades. So air generally went through the fans from the front to the back. So if you were looking at the good side of the fan, air was being taken in and pushed out the back. This was fine if you had this at the front, you had the good side on display. If you're going to have it exhausting at the top, again, you had the good side facing into the case, exhausting at the rear, the good side. The problem came if you wanted to have intake on the side. This did not look very well facing into the case, or intake from the bottom. Again, this did not look very well facing up to the bottom. And again, it's exactly the same with this side. It doesn't look particularly good. So the main problem with this type of device is each fan had its own PWM and ARGB cable, meaning you had loads of mess of cables at the back, and the fans had to be installed separately. So how things changed was that a lot of fans came where you were able to join them together. These are example of Lian Li Uni fans, and they simply clip in together you're going to have one set of cables at the end to control up to 3 or 4 fans. And you remember the ones I showed you on the I/O that connected magnetically? So that things have involved rather than having to actually clip them in. There is certain fans where at the end you're just going to have a PWM and RGB cable, so you're going to be able to run those through your motherboard software. Although what's becoming more common with the fans is you're going to plug them into a hub. That hub is connected by a USB cable into your motherboard. And remember, anytime you hear a USB cable, you're going to have to use some proprietary software to then control the effects on those fans. So the big advantage of this, fewer cables, you get much more lighting effects. You're able to control lighting effects on different bits of the fans. Lots more customizable options, but the downside is you're going to have to run software to control the effects on these fans. And then we've got fans that actually have screens on them. So you can have 3 different lighting effects on the fans, a screen in the middle where you can play videos, pictures, or display your system information. But again, the big downside of these is the cost, and the other big downside is having software running all the time. But they do look absolutely stunning when you put them into a build. So initially when these fans come out, they still shared the same problem, whereas the back of the fans didn't look very good. So if you had this at the bottom of the case set to intake, this was the side was on display, so it didn't look great. So what they've done now is a lot of the fans have reverse fan blades. So when the fan turns in this orientation, it's actually drawing air in the back of the fan and into the case. So if you had this at the bottom, you would have the good side of the fan on display. So that's just a quick run through the fans. I can't cover everything. Every manufacturer has brought out different variations of fans, but it just gives you an idea of what you should be looking for when you're installing additional fans into a build. Okay, so now we've done that, let's take a look at the case. So there is general rules in the direction of airflow through a case. So the front of the case should be intake. Generally have some sort of filter on the front of the case to filter the air, so you're bringing cool, filtered air without any dust in it into your build. Having the front of the case set to exhaust is a terrible idea because you're going to have hot air coming out and hitting you in the face. So front of the case is always intake. If you're going to have fans at the bottom of the case, they should be set to intake as well. And the reason for this is your graphics card is going to be installed here with its fans at the bottom trying to draw air in. And if you were exhausting air out the bottom, for the first thing is it makes no sense because that would be fighting with your graphics card's fans which want to take air in. So you can see at the bottom of this case, we've got 2 fans installed. They're not reverse blade fans, so the good side of the fans is facing the bottom of the case. We've got the bad side of the fans facing us. So this means they're going to be taking air from the bottom through these perforated panels on the side and bringing it up into our graphics card, which is just the way we want it. So you'll notice that Leon Lee have decided not to put ARGB on these fans like they have at the front. Big reason for this is the last thing you want is lights on these fans. What they would do is light up the whole of the bottom compartment. When you look through the mesh, you're going to see all your power supply cables at the bottom. So a tip, if you are installing fans on the power supply shroud and you've got mesh panels at the bottom, I would try and avoid ARGB on them because it's just going to light up the bottom of the compartment showing all your power supply cables. So if we look at the direction of airflow, we're going to have air coming in from here, in from the bottom, and we're going to want to exhaust it out the top and out the rear of the case. The last thing you want in a case is lots of air hitting each other because it won't move anywhere. So there has to be a gradual flow of air in the case. And in general, it's in from the front, in from the bottom, out the top and out the rear. So that's why we've installed the fans in the radiator this way. The good side is facing the front, bad side the top. Air is going to go up and out the case. So a question I see a lot of people asking in the comments, should I not set my rear fan to intake? It's going to bring more cool air into my CPU cooler and improve its temperatures. 2 problems with this. The first is look at the massive holes we have at the rear of the case. These are unfiltered, so as well as bringing air in, we're going to be bringing loads of dust into the build. Remember, at the bottom we've got fine mesh, and at the front of this case we've got fine mesh, which is hopefully going to keep the dust out. As the other reason we've mentioned, you need a path of airflow through the case. So we have air coming from the front, air coming from the rear, and meeting in the middle. It's going to create a lot of turbulence, it's going to bring noise, and the path of that airflow is going to be very inefficient. So stick to the simple rules: intake at the bottom, intake at the front, exhaust at the top, and exhaust at the rear, and you won't have any problems. Next thing you may have heard people talk about is positive pressure and negative pressure inside the case. So in general, positive pressure and neutral pressure is good. Negative pressure is something that you want to avoid. So for example, if we had lots of exhaust fans and very few intake fans, we would have more fans trying to blow air out of the case. So air would still need to come into the case from somewhere, so it would suck in through these unventilated panels and be exhausted out, so we'd have negative pressure inside the case, and air would be drawn in through all the gaps in the panels where there's no filters, and that brings dust into the build. So in general, you want to have your fans balanced, or more air being drawn in from the fans than exhausted, and that means that you're not going to get air which is unfiltered with dust in it drawn into the case. So what some people will tell you is you add up your intake fans and you add up your exhaust fans. So we've got 1, 2, 3, 4 fans bringing air in, and we've got 3 fans exhausting it. So they'll tell you, okay, 4 fans in, 3 fans out, that is positive pressure in the case, and you're safe enough, you're not going to get dust drawn in. So it's not quite as simple as this. We have different fans which will each move different amounts of airflow and each have different degrees of static pressure. And other things will affect the airflow. For example, the fans at the top have a radiator, so they are not going to be able to push as much air as if they were going straight against the exhaust of the case without the radiator in its way. Likewise, if you've got dust filters, they're going to impair the airflow as well. And also the fans can run at different speeds depending on how you've set them up. So what I would say, it's not quite as simple, but as a general rule, try and balance your in and out fans or have more intake than exhaust. So if I was looking at this case, I would say we've got 4 fans bringing air in, which are relatively unrestricted. There's no additional dust filters. We've just got fine mesh, and we've got 3 fans at the top, which are exhausting out through a radiator. So I would say this case probably has positive pressure in it. If we did want to add an additional fan in at the rear, we could, and probably do it safely, 4 in and 4 out. I still think we're probably going to have positive pressure in the case, but there's no need to do this in terms of airflow unless you like the look of a fan at the rear. So taking a look at our fan text case, this time we've got 3 fans at the front. Good side of the fan's on display, so it's going to be acting as a source of intake. We do have a little bit more resistance because this time we've got a dust filter as well as a mesh panel. And again, if we look at the top, the good side of the fan is facing into the case, so they're going to be blowing air out the top through the radiator, and we've got the good side of our fan at the rear. It's going to be blowing air out the back of the case. So in this case, we've got 3 fans at the front bringing air in, 3 fans at the top exhausting it, and 1 fan at the rear exhausting it. Again, I'm not worried about negative pressure because the 3 fans at the front are going to be generally quite unrestricted, like the fan at the rear, but there's going to be quite a bit of restriction to the airflow in these fans at the top of the case. We do have 3 fan mounting locations at the bottom of the case, and again, following our rules, if we wanted to add fans in, we'd be having them set to intake. Although with the 3 fans at the front, they'll be bringing plenty of cool air into our graphics card, so I think 3 fans at the bottom is unnecessary. Again, remembering the rules, we've got a mesh panel down here, so we are adding fans at the bottom. We probably don't want to have any lighting on them. And because we would have the fan set to intake, we would have the bad side of the fans on display if we use standard fans. So if I did want to add some in, I would be looking for reverse blade fans. So this is just a standard PWM fan. There's no RGB on it, so we've just got a 4-pin PWM cable coming from it. So importantly, in orientating this cable in the case, we're going to want to have this cable near to the cutout at the back. So this is the right orientation to insert it in. For example, if we put it in this orientation, the cable would be running in the main body of the case. There'd be less cable to reach the headers, and also it would look more untidy. So first thing I'm going to do is pass the cable through to the back, and then I'm just going to pull the fan up into place. And then we'll secure the fan into place with the 4 included fan screws, and there's fan screws included with the case, and you also get them with the fan. And then we can just pass the fan cable back through to the main body of the case, and we'll get it plugged into a fan header at the bottom. So that's what the fan looks like installed at the back. I don't think it's necessary, so I'm going to go ahead and remove it. So this brings us on to the most exciting part of any PC build, and that is the graphics card. And if you're building yourself a gaming PC, this should be the most expensive component in your build. If it's a video editing PC, it depends what package you're using. I use DaVinci Resolve, where you get a big benefit from having a good graphics card. There's other packages where your graphics card doesn't really do that much lifting, so there's no need to spend on the most expensive one. So what I would say is look at the tasks you're wanting to use the PC for, and look at the benchmarks. If you're using it for gaming, look at the games you want to play, look at the different benchmarks in terms of the frame rates that you're going to be getting from it, look at the monitor you're using, what resolution are you going to be using, how fast will that monitor go, and are you actually going to see any benefit by spending a fortune on a graphics card. Again, if you're using your PC for content creation, Puget Systems is where I would go to. look at the difference the graphics card will make to your workflow, and that's going to help you decide how much you should be spending on one. So in terms of the manufacturers of the graphics card, there's three big players there: NVIDIA, AMD, and Intel. So when you're trying to decide between the manufacturers, some people do have brand loyalty. They'll only go with NVIDIA, they'll only go with AMD. What I would say is look at the benchmarks, look at the features each of the graphics card offers, and look at the price to performance, and use that to help you make your mind up. When it comes to the power cables, there's really only the high-end and mid-range NVIDIA cards that are using those 12-volt high powers or 12-volt 2x6 cables. If you're going low-end NVIDIA, AMD or Intel, you're generally using the 8-pin PCIe cables, so that may be something to look at when you're trying to pick your power supply. Just remember, if you are using those standard PCIe cables, or if you're using standard PCIe cables to plug into an adapter that comes with your graphics card, try not to daisy chain them. You should be using a separate cable from your power supply for each port on the adapter, or into each port on the graphics card if at all possible. So certainly a trend in graphics cards over the last year is they have just been getting bigger and bigger. So a feature you may want to look at in the case is a GPU support bracket. Our Lian Li case has a GPU support bracket, so I'll be showing you how to use it. Our Phanteks case doesn't, but thankfully most of the graphics cards will include a GPU support bracket in them. So I'll show you how to install those later on. And the final thing I want to cover is mounting your graphics card vertically. It gives you a great look at the fans on the side of the graphics card, but it does come at extra cost, and there's a few things to be careful about. In terms of how you do it, in some cases you will be able to rotate the PCI extension slot brackets round, turning them into a vertical position. All you're going to need to do is pick up a riser cable to plug into the bottom of your graphics card. In other cases, you're not going to be able to do that, so you're going to need a bracket as well as a riser cable. The other thing you're going to have to be really careful with is what generation of PCIe cable you get. So if you're using the new 5000 series graphics card, you're going to need a Gen 5 riser cable. And if you're going to be using the 4000 or 3000 series graphics card, it's a Gen 4 riser cable that you want. And the final thing to mention, if you are thinking about your graphics card vertically, make sure the fans in the graphics card are well enough away from the tempered glass panel. If they're right up against the tempered glass panel, they might not get enough airflow and the graphics card can run hot. So we're now ready to install our graphics card, and as a rule you're going to want to install your graphics card in the top slot to get the fastest speeds. So I've lined our graphics card up with this top slot, and it lines up with the second expansion slot bracket. Our graphics card has got two brackets on it, so we're going to need to remove the second and third expansion slot bracket from the top. So take a look at your graphics card, see how many brackets is on it, and that's going to tell you how many to remove. And you're going to want to line it up and see, because sometimes the slot on the motherboard will be in a variety of different positions. So each of the brackets is held on with a thumb screw, which we need to remove. And then with the thumb screws removed, we can pull the brackets towards us to remove them from the case. So how we open this slot on the motherboard depends on the motherboard that we've got. So this motherboard features Asus's Q-Slim technology. So all we need to do is install our graphics card into the slot, and it's going to automatically close. To remove our graphics card, we just need to pull the graphics card from the left-hand side to remove it from the slot. If we pull from the middle of the right-hand side, the graphics card is going to stay in the slot. There is other motherboards where you're going to have a little button over to the right-hand side to press to open and close the slot. And I've used some of the MSI's ones recently where you have to do that. And there is other motherboards where you're not going to have to do anything at the start to open the slot, and there's a button that you can press to open it. Again, some older motherboards, you're not going to have any special technology. You're just simply going to have these clips at the bottom, which you need to push open. You can install your graphics card, and as you install it, the clip will close. But the big advantage of this technology is once your graphics card is in blocking the slot up, it's very difficult to press these buttons to get them opened up. The other thing you'll notice, we have a GPU support bracket at the front of the case, and there's three different slots we can install it in, and which slot you use depends on the length of your graphics card. If your graphics card is less than 285mm, you're not going to be able to use the slot cover. Between 285 and 315, you want it in the first slot cover. Between 316 and 345 is the middle slot cover, and 346 to 375, it's the slot cover closest to the front, which is the one we're going to want to have it installed in. So to move it, we're just going to have to free up the thumb screw at the back. So we'll move it one slot along and then just put the thumb screw in loosely, which means that after we've installed our graphics card, we're going to slide this up to where it provides support and then tighten the thumb screw at the back to hold it in place. But before we install our graphics card, we're going to have this all the way down towards the bottom. Next, we can bring our graphics card into place, and what we're going to do is try and line it up with that top slot. And once we're happy we've got everything lined up, we're going to apply some firm pressure to the graphics card. and it's going to clip into place. And then we can secure it using the 2 thumb screws that we removed earlier on. So we do take a look at our graphics card. You can see there is a little bit of sag on it, and just need lifted up a little bit at this side. So what I'm going to do is put my hand under the support bracket, lift the graphics card up to where I'm happy it's straight, and then I'm just going to tighten the thumb screw at the back. And to make sure everything stays in the right place, we'll just give the thumb screw a tighten up with a screwdriver. Next, we just need to bring our graphics power cable in through the cutout at the bottom, and then we can line the connector up with the graphics card and push it in. And it's really important that we make sure we've got a nice satisfying click when it goes in, because as I've said, this is the big problem with these, not pushing the connectors all the way in. And then I'm just going to use the cable combs that come on the cable to help organize the cable. So another thing we really want to avoid is putting a big bend in this cable, particularly round about the connector. So 2 things to check. I do have our 12-volt high power cable sitting well away from the fan at the bottom, so it's definitely not obstructing the fan blades. And anytime you use a GPU support bracket, you want to check it's not obstructing the fans on the graphics card. So I can check it's well away from the fan, and the fan at the bottom can spin without any obstruction. So the first step for installing our graphics card is to secure our GPU support bracket to the graphics card. So this little bracket's going to go here, and then we're going to take a screw with a washer on it and install it, and then we'll set the second one into place. We can then set the shorter bracket that comes with the graphics card into place, and we'll secure it using a thumb screw. So now we've got that bracket installed, I'm just going to pull this forward and tighten up the screws. So I'm just going to loosen this slightly so the foot is held down. And to get the bracket to fit, we're just going to have to rotate this bit around 180 degrees, and then it can slide in at the bottom. So we're going to be able to install our graphics card. Then all we need to do is loosen the thumb screw, and this is going to lower down and attach in the case. So again, I've lined our graphics card up. In this case, we've only got 1 PCIe slot, and it lines up with the second slot down. We've got 3 brackets on our graphics card, so we're going to need to remove the 2nd, 3rd, and 4th slot cover from the top. So this is one of these motherboards with the little button to open the slot cover. So all we need to do is press the button, and you'll notice that opens the clip, and then when we install the graphics card, the clip will close. And as I said, the big advantage is you're going to have this little button. When you want to take your graphics card out, you can press it without having to worry about getting your finger in here to open a clip. Okay, so next thing we can do is line our graphics card up with a slot. And once we're happy we've got our graphics card lined up, it's just some firm pressure, and it's going to clip into place. And then we'll go ahead and secure it into place with the 3 thumb screws. So again, with such a big graphics card, a little bit of sag is to be expected. So what we can do is release this thumb screw at the top a little bit, and that's going to allow the bracket to fall down to the bottom. Now this bracket is magnetically attached, so it will sit at the bottom. So all I'm going to do is lift the graphics card up to where I'm happy it's sitting nice and straight, and then we can just tighten up this thumb screw to hold the bracket in that position. So we can go ahead and bring our 12-volt 2x6 cable through the cutout at the bottom. We can line the cable up with the graphics card and push into place. And again, we're going to make sure we get a nice satisfying click. And then we can just pull all the excess cable down to the bottom. So you guys are probably thinking the same thing as what I'm thinking. This would look so much better with a white graphics card. And this had been my preference. There is a white version of the Aorus Master, and that would have been what I would ideally have gone with. Unfortunately, it wasn't available, and this was the only one that Aorus could send. I was still keen to show you guys the latest and greatest graphics cards. So if you are thinking of copying this build, the only thing I would change would be getting the white version of this card. Okay, last thing to do is some cable management and get our panels back on. So we do have this central raceway with Velcro cable straps to help organize our cables. We have additional cable tie down points over towards this side, and there's some cable ties in the case accessory box we can use for here. The big thing that we want to avoid is making sure all the cables are clear of these cutouts so they can't be seen from the front. Before we replace the tempered glass panel, we're going to need to peel the plastic protection off the inside. We can then replace the panel and tighten up the thumb screws. And then the bit I look forward to for any PC build is the peel. So it's almost time for the moment of truth where we need to flip the power switch and see what happens, but with one step to do before that. We need to make a Windows 11 bootable USB drive. So you're going to need a USB drive. It needs to be at least 8 GB and it needs to ideally be empty. The reason it needs to be empty because everything on the drive is going to get wiped during the installation process. You are going to need another PC to create this on, so I'm going to use my own PC. We've got my USB drive and we'll plug it into the PC. So we're going to scan down to create Windows 11 installation media and click download now. We can double click on the file, click yes. We're going to accept the agreement. So it's going to fill in the language and the edition that you want. If you want to change these, you can uncheck this box and you're going to have access to these drop down menus. And we'll click on next. So we're going to want to create a USB flash drive, and as I've mentioned, it needs to be 8 GB and everything on this is going to be wiped. So when we click next, it's going to find our removable drive, which is this one here. I'm going to select it, click next. Okay, so we can go ahead and click on finish. We can then eject our drive and we can pull it out of the PC. The whole process took around about 15 minutes or so, so we're ready for the next step. Next, we're ready to get everything connected up to our PC, so we'll plug in our power cable. We're going to need to plug in our HDMI cable, our DisplayPort cable. Now importantly, this goes into your graphics card, not the connectors on your motherboard. We can plug in the antennas for our Wi-Fi. Or if you prefer, you can plug in an Ethernet cable or both. We can plug in our keyboard and our mouse. And importantly, we can plug in our Windows 11 bootable USB drive. So we've now reached the most nerve-wracking bit of any PC build. We're going to have to flip the power switch and see if it works. So let's go ahead. So good signs. I can hear water moving in the cooler. We've got fans spinning. Lights are appearing. So we're just going to have to watch the monitor and see what happens. So if for some reason your PC doesn't post, I have made a troubleshooting video and you'll find a link to it in the description. So the PC had switched itself on and off. That's nothing to be alarmed about. We can hear the fans are ramping down, so that's a good sign that hopefully we'll be getting something on the screen. And there we go. So this screen will appear the first time you power on the PC. So it's telling us to press F1 to enter the BIOS, so we'll do that. So this is what the BIOS homepage looks like, and we'll be coming back here later on. I'm going to show you how to update the BIOS. I'll show you how to adjust the important settings, such as enable the XMP profile on our RAM and adjusting the fan curves. I don't like making any changes to the BIOS initially until we've installed Windows. The last thing we want to do is make our PC unstable during the Windows installation. So the easiest thing is just to leave the BIOS. We can save the settings by pressing F10. It's going to tell us we haven't actually made any changes, and we're just going to click on OK. So what the PC will do now is it will restart. This time it will hopefully find our bootable USB drive in the back of the PC and boot off that, because the SSDs that we have installed in the system are completely blank, so it won't be able to boot from those. So it's just a matter of waiting, and the next thing we're looking to see is the Windows installer icon. Okay, so there we're through to the Windows installation screen. So next step is to install Windows 11. Okay, so I'm from the United Kingdom, so I'm just going to click on Next. We'll click Next again, and what we're looking to do is install Windows 11. So we'll agree to the terms and conditions and click on Next. So if you've already got a Windows product key, you can go ahead and enter it at this stage. I'm going to be getting mine later on. We'll show you that once we have installed Windows on the PC. So what I'm going to do is click I don't have a product key, and then we're going to need to select the version of Windows 11 that I'm going to get a product key for. So I'm going to get one for Windows 11 Pro and click on Next. We can click Accept. So we now need to decide where we want to install Windows 11. So 3 drives are showing up. The first 2 are the SSDs we have installed in the system, and the third drive is our bootable USB drive. You'll see now why I've said it's important. If you've got multiple drives of the same capacity, you might not want to plug them all in at this stage. So you can see our drives are labeled as disk 0 and disk 1. So if we had 2 drives of 1 terabyte capacity and we wanted to install in a particular one of these, it might be difficult to identify which was the right drive. So if you do have this situation, what I would recommend doing is just plugging in the drive that you want to install Windows on. You can go ahead and install Windows and then install the drive at a later stage. Now, in general, I would recommend installing Windows on the lower capacity drive, providing there's enough space on it for your installation, and leave the bigger drive 3 for your video files if you're going to do it for content creation or a games library. For the particular reasons I'm building this PC, I am, however, going to install it on the bigger drive. So I'll select it and click Next. And then we can click on Install. So at this stage, Windows has been installed. We just need to set it up so we can remove the USB drive from the PC. So I'm from the United Kingdom. I'm just going to click on Yes. And again, I'm happy with the United Kingdom keyboard. I don't want a secondary keyboard, so I'm going to click Skip. So although I do have an Ethernet cable plugged into our PC, it's not showing up a connection, and this could be because of a lack of a driver. So what we're going to want to do on another PC is head over to our motherboards page. We're going to click on Support. We're then going to click on Driver and Utility. We're going to select our operating system, Windows 11 64-bit, and we can see here we've got our LAN drivers. I'm just going to show them all. So because our PC's got two different Ethernet ports, we've got two different Ethernet drivers for each port that we're going to plug into. So the Realtek driver is for our 5 gigabit port, and the Intel driver is for our 2.5 gigabit port. So that's the one we're plugged into. So I'm going to go ahead and download it. I'm also going to download the Wi-Fi driver in case of any problem with Ethernet. So we'll click on Download. Then if we head over to our Downloads folder, I'm just going to extract the contents of each of these files. And then I'm going to copy the two folders and paste them onto a USB drive. So we're going to have to repeat the initial setup steps. So now what we can do is click on Install Driver. I've plugged in our USB drive. So I can go ahead and select our Ethernet driver, and we'll click on Select Folder. So what it's going to do, it's going to search for the folder for drivers and go ahead and install them. And there we go, that's us connected to the internet. So it's telling us we have to reboot now, so we'll go ahead and do that. If you don't have an Ethernet connection or you'd rather install the Wi-Fi drivers, just go ahead and select the folder that has your Wi-Fi drivers in it. After the drivers have been installed, you'll see the available Wi-Fi network. You can go ahead and connect to your network and click Next to continue. So if you do have any problem installing your drivers, I'll show you how to set Windows up without an internet connection. Another reason for doing this is if you don't want to use a Microsoft account. So at this stage, what you're going to want to do is click on Shift and F10. And then after the System32, you're going to type exactly what I have got on the screen and press Enter. At this stage, your PC is going to reboot, and then we're going to need to go ahead and do the initial options again. So this time we've got an additional option down here, which is I don't have internet. So we can go ahead and click on it, and then it's going to get you to set up a password and go through some security questions, and you're going to be able to set up Windows without an internet connection or a Microsoft account. If you're doing this because you don't have an internet connection and you do want the Microsoft account, all you can do is once you've got into Windows, install the drivers, and then you can add your Microsoft account. Okay, so we need to name our PC. I'm going to call it LANCool 207 and click on Next. I'm going to set up for personal use. Click Next. The PC is just going to check for updates at this stage, and it might take a little bit of time. Okay, next thing to do is sign in to our Microsoft account. And if you don't have a Microsoft account, you can go ahead and create one here. And then we can create a PIN. In the next lot of screens, you just need to pick the options that you want. So if you have done PC builds in your account before, there may be some backups you can restore from. I want to set this up as a new PC, so I'm going to click on More Options. I click Set Up as a new PC and Set Up as a new PC. I'm just going to skip through these next lot of screens, so we'll skip. Obviously, if you have different options, go ahead and pick whatever you want. Okay, so that's Windows 11 installed. We're getting a pop-up about downloading ASUS Driver Hub. So I'm going to click on Yes, because this will simplify the installation of our drivers. We're going to need to scan down to the bottom and click Accept, and click on Finish. Okay, so the first thing I like to do in any PC is make sure Windows is fully up to date. So we click on the Windows icon, we'll click on the Settings, we'll click on Windows Updates, and we'll click on Download and Install. So we're going to keep coming back here, and we're only going to move forward once there's no further updates available. Okay, so whenever I click on check for updates, there's no further updates available, so Windows is fully up to date. The next thing I want to do is install our drivers. So we'll click on ASUS Driver Hub, click yes. Okay, so what this has done is find a whole load of drivers for our particular PC, and there's also some software packages as well. Now, you can install the drivers through here, or because we're going to be installing Armoury Crate, it's also possible to install them with Armoury Crate as well. I'll show you installing the chipset driver from here, because that's definitely one that we're going to want. So to complete the installation, we are going to have to restart our PC, so we'll click on Restart Now, and then we'll go back into the ASUS Driver Hub. Okay, so you could of course just repeat this process installing the rest of the drivers, but I normally install them using Armoury Crate. So I'm going to go ahead and install Armoury Crate. We are going to need the Armoury Crate to control the RGB effects on our motherboard, our RAM, and on our graphics card. So I'm just going to install the Armoury Crate and click on Start. Obviously you don't want Armoury Crate running in the background, you can install the rest of your drivers just like I showed you how to install the chipset driver. And we can click on I understand, click yes. Okay, so we can click on Reopen Up. We need to scan down the bottom and click that we agree. I'm just going to skip this for now and click on Cancel. So we're going to go ahead and click on the Tools tab, and the first tab is Drivers. So it's going to scan the drivers that we have. So Armoury Crate has scanned our system to see what drivers we have, and a lot of them have already been installed or are up to date. So the additional ones, the LAN driver, which we do want, so I'm going to leave that on. The serial I/O driver, we're going to want that. Intel Smart Sound Technology, the management intake, and our audio drivers. And you can see a lot of our other drivers, our Wi-Fi drivers, our LAN drivers, and our chipset have already been installed. So I'm happy with all the things it's installing. It's not installing anything unnecessary, which is why I trust this program in terms of what it puts on. So I'm going to click Download and Install. And this will take a little bit of time. Okay, so that's all our drivers installed. To finish the installation, we're going to need to click on Restart Now. So the only driver that we won't get from the Armoury Crate that we need is the one for our graphics card, and we're going to get that from the NVIDIA app. And you'll find links to everything that I show you in the description. So we'll click on Download Now, and we can go ahead and install the file. Click yes, and yes again. We'll agree and continue. So the first thing to select is what type of drivers you want, and that depends what you're using your PC for. If you're using your PC mainly for gaming, you're going to want to get the game ready drivers. If you're using it for content creation, pick the studio drivers. So for this PC, I'll set it up for gaming. So we'll click the game ready drivers and click next. So you can select whether you want the app to optimize things. I'll just leave that on and click next, and done. We can head over to the drivers tab. You see it's found a game ready driver, so we'll click on download, and we'll click on install and click yes. I'm happy just for an express installation, so we'll click on continue. And it is normal for your screen to flash during this installation, so don't be alarmed when it does this. Okay, so that's everything installed. We can click on close. Okay, next thing I want to show you is how to get all your drives to show up on the PC, because if we go over to this PC, what you'll notice is only our 2 terabyte drive is showing up, and the 1 terabyte drive that we've installed isn't appearing. So to get it to show up, we're going to need to type disk management, and then create and format hard disk partitions is going to come up, so we'll click on it. So it's found our additional drive, disk 0, so we're just going to click on OK. And we can show it's currently showing up as unallocated space, and disk 1 is our 2 terabyte drive, which is Windows installed on it. So we just need to right click on the drive, click New Simple Volume, click Next, Next. If we want to change the letter from D, we can do it here, but we'll click Next. And then we can name the drive and click on Next and Finish. Okay, so you now see the drive is showing up, and if we go back to this PC, you can now see that both our drives are available. Okay, the next thing I want to do is show you how to activate Windows 11. So you can see here our copy is not active. There is an option to get a license from the Microsoft Store, so let's just see what they're charging for it out of interest. So just under £220, so we definitely don't want to get it from here. There's a whole variety of different sites selling Windows keys, so I'm going to take this Windows 11 Professional key here and click to add to cart. I'm going to view the cart, and we'll click on Apply Coupon, and we'll click Proceed to Checkout. So there you go, so we've got it for half price, so $15. So we'll click on Proceed to Checkout, and I'm just going to put my details in and pay for this. So after about 5 minutes, we're able to access our code, so we'll click on Copy, So head back over to settings, we can click on System and Activate Now. We can click Change Product Key, and we can paste the product key into the box and click on Next and Activate and Close. And there we go, Windows is currently active. Okay, next thing I want to do is show you how to update the BIOS. So we're going to click on the Support tab on our Motherboards page. We'll click Drivers and Utility, BIOS and Firmware. And we've got the BIOS tab here. We can just expand it to show all. Okay, so we've got the different versions of the BIOS here. In general, I would recommend going for the latest stable version. So you can see the top version is a beta version. So we'll take the version before that and click on Download. So we'll head over to our Downloads folder. So we're just going to copy the zip file and put that onto our USB drive. Okay, at the end of the BIOS, what we're going to need to do is restart our computer. So we'll click on the power icon and click on Restart. What we're going to do once the screen goes blank, we're going to start pressing the delete key. And then as the PC restarts, it should load into the BIOS as long as we press delete. So you can see our current version of the BIOS here, and that's from the 22nd of October last year. So we're going to click on the Tool tab. We'll click on the Asus Easy Flash 4 utility. We can click on our drive, and here is the zip folder. So this is going to contain our BIOS and the management engine. So we'll click on Yes, and Yes again. So we can see the version of the BIOS and the date of the BIOS that's going to be updated. We'll click on Yes. So what's really important here is that your PC does not lose power during this update. So don't do this if there's a chance that the power is going to go off. And whatever you do, don't touch your PC, go anywhere near the cables where there's a risk of you pulling a cable out during the update process. Okay, so that's the BIOS updated. We can click Enter and the PC will reboot. Okay, so that's our BIOS updated. We can go ahead and press F1 to enter the BIOS. Okay, so we can see our BIOS has been updated to the latest stable version. So we can go ahead and click on the Easy mode. And I think this is a good place to get an overview of our system to make sure everything is behaving as it should. So we can see our CPU temperature here, and it's always worth having a check of this when you've built a new PC. I have built a PC before and found the idle temperatures were up in the 60s, and this very quickly alerted me to a problem with the IO pump. So we can see a lot of other information on the screen. In particular, we've got our RAM, so it's currently running at 5600 mega transfers per second, but we can enable the XMP profile. So all we need to do is click on it and click Enabled. And that will increase the frequency of our RAM up to 7200 mega transfers per second. We can see our drives, so we've got our Adata Legend, our Gen 5 drive, and our Gen 4 2 terabyte drive, and we've also still got our USB drive that we use to update the BIOS. And here we can see our fan speeds. So we've got our AIO pump, we've got the fans on the radiator plugged into the CPU fan, and we've got our two different groups of system fans, our front and bottom fans, and we can see the speed that they're currently running at. If we want to make any adjustments to these, we can click on Q fan control. And again, here we've got a little bit more information on a number of different sources of temperature. So starting off with our CPU fan, we can see the current fan curve it's running in. That is the standard fan curve. The CPU fan control is auto detect. In older motherboards, you did have to select between DC and PWM mode. So for example, if I switch over to DC mode, you'll notice that the fan curve jumps up massively and there's a lot of extra noise happening in the background. And this is what I'd mentioned before. With DC mode, your idle speeds tend to have to be higher. If we go and pick PWM mode, you'll notice that the curve jumps all the way down. So the auto detect mode had actually picked up that we had a PWM device and ran it in the PWM mode. In terms of the source, it's taken its temperature off the CPU, and there is other adjustments that we can make here. If we want, we can change the fan curve slightly. So we want to pick the silent curve, we can do that. If we want to run it at full speed, it's possible, not that we're going to want to do that. And if we want to make up our own manual curve, we can do this, and then we're just going to be able to drag the points on the curve to exactly where we want them. So I'm happy enough for the CPU cooler to leave it in the standard curve. We'll just leave it on PWM mode. Auto detect was fine as well. So we'll head over to our AIO pump. So it's currently running at full speed in auto detect. We can see the temperature is going to be taking that from the CPU and the current speed. And I normally just do run the pump at 100%. So we'll take a look at our chassis fans. Okay, so we've got one group of fans plugged into chassis fan header number 2. You can see by the fan curve, these are probably already running in PWM mode using the auto detect. If we want to switch to DC mode, you'll see again that the default fan curve is going to jump up massively and there's a whole load of noise coming in the background. So I'm just going to select PWM mode, as though as I mentioned, there's probably no need to, we can just leave it in auto detect. Now, the one thing that this is doing is it is taking its temperature source off the CPU. So when our CPU temperature increases, the fan speeds in the case are going to bring more cooler into the case and more cooler into our AIO. So this is great in terms of cooling, but not great when you're using your PC and sitting beside it. As we've said, our CPU is idling round about here, and if we do some simple tasks in Windows, it's going to be on this steep part of the curve. So all our fans in our system are constantly going to be ramping up and ramping down, and it can be quite annoying. There's a few different ways we can handle this. The first thing we can do is head over to the manual curve, and we can flatten this bit of the curve out ourselves. Alternatively, what we can do is change the temperature source that it's reacting to. So we can go into here and, for example, pick motherboard. Motherboard is going to be a much more stable temperature source, and it's going to mean that our fans are probably going to run in round about that 20 to 30% most of the time. Not as good for cooling, but it will be a much more pleasant PC to sit beside and a great way of reducing noise. What I'm planning on doing is some thermal testing, so I'm going to leave everything as it was. So we'll go back to the CPU. The only thing I'm going to do is go for the silent fan curve profile for our case fans. And it's just going to flatten this curve down a little bit. So I'll head over to our other set of case fans. Again, I'm just going to select PWM mode to make sure, although it looks like it's already running in the PWM mode. And I'm going to leave the source as CPU until I've done my thermal testing. We'll click on silent, then click on exit. Okay, so that's the main changes that I want to make in the BIOS, but there is a whole load of options in the BIOS that you can have a read about, and there may be other options that you want to do. For example, you want to do the overclocking, it's the tweaker tab that you're going to go to. In the advanced tab, there's a whole lot of other options as well. But to save the settings that we've changed, all we need to do is click on the exit tab, and we're going to click on save changes and reset. So what it's going to do, it's going to give us a summary of the things that we have changed. So we're getting lots of information about the RAM that we have adjusted, enabling the XMP profile, and then also the changes that we have made to our fan curves. So we'll click OK to accept things, and then the PC will boot into Windows. Okay, so that's us back in Windows. The first thing I want to do is check that our RAM is currently running at the correct speed. So we'll hit Ctrl-Alt-Delete and click on Task Manager. We're going to click on the Performance tab, and we'll just maximize that. And then we can click on our memory. And we can see here we've got 48 gigabytes of RAM installed, and it's running at the correct speed at 7200 megatransfers per second. This is also quite a useful place to disable startup apps that you don't want starting up. So I'm not planning on using the OneDrive, so I'm just going to disable it. Just having a look at what else is running, we can see that the ASUS Driver Hub update is currently running in the background, and we're not going to be using that now. We're using Armory Crate, so I'm just going to get rid of it. So we can right click here and click on install and on install. So that's better. We have nothing running in the background that we don't want running. If you want to customize the taskbar, we can just right click on the taskbar and go for taskbar settings. We can change the appearance of this. So if we just want a search icon only, and we can get rid of the task view and the widgets, and that's going to make things just a little bit cleaner. The other thing, if you don't like the background, you can just right click on the background and click on personalize, and then you've got the option to change to a different background. So we'll just go for this one. If you want to go with a custom icon, you can just go ahead and download the picture file. I've got a picture saved in my downloads. We can just click set as desktop background. So there we go, I think that's looking better already. If we head over to the system tab and then click on display, the other important thing that's worth checking is that we've got the right resolution set for our monitor. So the first thing you want to check is your display resolution, that you've got the maximum that your monitor can support. My monitor can support much more than 1080p, but I'm recording this using an ATEM Mini Pro, and that the maximum output for the ATEM Mini Pro is 1080p, so that's why it's limited to this. The other thing you're going to want to do is check the refresh rate. So we go down to advanced display settings, and again, you're going to want to select the maximum refresh rate. You can see here I'm using Blackmagic's Design ATEM Mini Pro, and the maximum refresh rate for it is 60 Hertz. Although if I was using my monitor, it would be much higher. So again, you're going to want to select the highest frequency that you can, and then check your monitor stable with it. The other thing I like to do is adjust the power plan. So we head over to System, we'll go to Power, and I like to change this to Performance. Over here, you've got the option to change when the PC sleeps as well. So last thing we need to do is get all the RGB in our system and customize our pump display. So as we've mentioned, we're going to do that in the Armoury Crate. So we can go ahead and click on the Windows icon and click on Armoury Crate. And we'll click Skip once and Cancel. Okay, so just before we do any customization, it is a good idea to check everything is up to date. So we can click on here in the update and go to the Update Center. And as you can see, we've got loads of updates for our motherboard, our graphics card, and our cooler. So it is important that we update everything. So the first thing I'm going to do is we'll go ahead and click on Update. So I'm just going to click on all the updates, and we'll only move forward once everything's up to date. So now that we've updated the amp, we can just click on Update All. Okay, so now that we've got everything up to date, we can click on the Aura tab, and you'll see it has found all our devices. So it's selected our motherboard, the lighting screen, we've got our graphics card, our memory, and the RGB strips and everything that's plugged into them. So what's plugged into them is the fans on our AIO, and also the two fans at the front of the case. Obviously we don't have to sync everything up, but I think I am going to for this. So we'll click on the Aura effects, and you'll see at the moment we're currently set to rainbow. So here all we need to do to change the effects, we can click, for example, on color cycle, and you'll notice that everything in the case is cycling through the different colors. So I am a big fan of static white in my build, so I'm going to click on static. At the moment it's currently set to red, so we want to change that. All we need to do is click on the red icon, and we just need to type in 255 into each of these boxes. And you'll notice that everything in the build has now turned to white. So you can see there the fans at the front of the case are set to white, as is all the RGB on our motherboard, our graphics card, our RAM, and the fans on the AIO. Okay, next thing to do is to adjust what's displayed on our screen. So to do that, we're going to click on the Device tab, and we're going to select our AIO, and we'll click on Cancel. So there is a variety of different effects here, so I can click on something else, and click on Apply, and that will change what is showing up on the AIO. So I'll show you another one. If you want, you can upload your own file, which can be a picture, a GIF, or a video. You can have the time displayed. So we'll try that. But the one I think I'm probably going to go for is a hardware monitor. So under the hardware monitor, I'm going to go for triple display. And we just have to select what is displayed. So CPU temperature seems good. Let's see what other temperatures we have. So we can go for GPU temperature, and then we have a choice of either frequencies, fan speed, voltages, or temperature. The other thing we could have is a liquid temperature in our AIO, and we'll click on Apply. If we wanted to have something different, we could have a frequency, and we could pick up, for example, our CPU, GPU, or memory frequency. Let's try the CPU frequency and click on Apply. So again, we have the option to pick a custom background, or we can upload our own. So let's see what else we have. I'll show you a few of these. So I think definitely this one seems to be my favorite. And I'm just going to I think I'll go with the liquid temperature. And click Apply. You've also got a whole lot more options, so we can head over to the fan control. So we can change our embedded microfan, which is the one cooling our VRM. So at the moment, we can see the current CPU temperature, and it's working along this fan curve here. That's the default fan curve. If we want to change that, we can pick one of these profiles. For example, we can go for the silent profile, or if we wanted to run on turbo, we can do that as well. And you can see that's going to bring the baseline up and kick that fan speed up. It's also possible to run it at full speed, not that you would want to because the noise is incredible. So I think for now, I'm just going to leave everything on the default fan curve. The other thing we can do, if we head over to our motherboard, you've got loads of options here. You can adjust your shutdown effects. You can look at your addressable headers and make changes here. We can change the lighting on the screen, so it's currently been synced with Aorus Sync, but if we want to change it, we can do that. So we can change that over to flicker. There's neon flare. We've got pulse. Or we can just sync it up with other effects, which is just a static white. So I think that's the one I'm going to leave it with. Okay, so that's everything set up and running just the way I wanted to. One thing I often do with a new PC is do some thermal testing, so I will show you how to do that. So the package I tend to use is AIDA64 Extreme, so we're going to click on download. I'll just go back and click download again. So we'll go ahead and open the file, click yes, and OK. Next, we'll accept the license terms and click next. And we'll go ahead and launch it. So you are able to get a 30-day free trial. So this is going to let you test your new PC, make sure everything's working, and you don't need to purchase a license unless you want to. I do have a product key, and I'm going to be using this installation to test further PCs. So I'm going to go ahead and enter my product code. Okay, so we're going to want to pick on the thermal stability test. And what we're going to want to do is click on preferences. So we just need to change what we want to look at. So I'm going to look at the CPU package. CPU is actually the socket temperature, so we'll turn it off. And I'm just going to look at the GPU temperature as well. So we'll just go for GPU 1. And I'm going to disable these other things. So the advantage of doing this is we're able to see just our CPU and GPU temperatures, so it's easier for me to see the important bits I'm looking at. So I'm going to stress everything with this. I'm going to stress our local disks, and I also want to stress our GPUs. Okay, so now that we've done that, we can click on Start. So what you'll see, our CPU load has spiked up to 100%, and our CPU and GPU temperatures are both increasing. You can see this bottom green line is the amount of thermal throttling. So with the older CPUs, particularly the 4900K, even with an AIO, we did get an awful lot of thermal throttling. You'll see these new CPUs, they're probably going to hit the 80s at the most in their peaks, and they generally shouldn't thermal throttle at all. In terms of the GPU temperature, I would expect this to run in the mid-60s. So everything at the moment is behaving as it should. But had I not installed the CPU killer right, this would be a useful test just to make sure everything was running well. So we might see high temperatures, we might see crashing when we're testing our PC, and that might alert us to something wrong with the setup. It is possible to take a look at other things while this is running. So over here, you're going to get a little bit more information. If you want more things to display here, you are going to have to do them in the preferences. So for example, under voltages, you've got a whole lot more information here. So you want to see what voltages go into your 12-volt high power connector to your graphics card, you can do that. Currents, powers, flows. We can look at our different clock speeds, so you can, a lot of options to put into here. And in terms of fan speeds, we can look at our AIO pump, our GPU fans. So it might be worth, before running your test, to have a look at the things that you're interested at and fill them all in here. Okay, so that's just coming up on 10 minutes. I'm going to click stop. And what you'll notice then is that the load on our CPU has come right the way down, and our CPU and GPU temperatures are falling quite quickly. So we can head over to our statistics and we can see what the maximum temperature, our maximum CPU temperature was 83, and our maximum GPU temperature is 67, which are very reasonable. I also recorded the noise while the thermal test was running, and we had noise levels of 53 decibels under load. In terms of noise now, with the PC idle, it's around about 34 decibels. And if we head back into our temperatures, we can see they've fallen down nicely. So graphics card currently sitting around about 33, CPU temperature 37, and still falling. So I'd be very happy with this PC. The parts are behaving exactly as I would expect them to, and the cooling is pretty good. Really happy with the idle noise levels. As I've mentioned, the only thing for me, I would need to use this PC in Windows to see are the fans kicking up and down during normal use, but I haven't noticed this during the installation. So I'm actually pretty happy with the way this PC is running and sounding. So now we come on to setting up our second PC, and I want to start off by showing you something different. I want to show you how to install the BIOS using the motherboard's BIOS flashback button. So there's a button on the back of the PC that will allow us to do this with the PC powered off. So there is certain situations you're going to maybe need to do this. If you've got an older motherboard and a newer CPU, and out of the box that motherboard didn't support the newer CPU. With the number of BIOS updates, it may support that CPU, but if your motherboard has been sitting in the box the whole time, it won't have had those BIOS updates. Previously, what you had to do was get an old CPU, update the BIOS, and then swap the CPU around, and it would work. More recently, motherboards have had BIOS flashback buttons on the back of them. Gigabyte call this QFlash Plus, and this button then allows you to be able to update the BIOS with the PC off. And then once the BIOS has been updated, the new CPU should work in it. So although this is an older B650E motherboard and we've got a new 9000 series CPU, because actually Gigabyte released this motherboard quite late, looking at the BIOS versions, the first version of the BIOS should support this CPU. So actually I could probably power this PC on and it would work, and I would be able to update the BIOS the same way as I showed you with our first PC. But you may find yourself in a situation with different hardware and need to use this, so I do want to show you how to do it. So two important bits of advice. The first would be only update your BIOS this way if you have no other choice. If your PC works, I would do it the way I've showed you with the first PC. And the second thing is, even if you think you have an incompatible CPU and BIOS, you lose nothing by trying to power the PC on. I've done this a number of times and actually been surprised because it does actually work, and then I've been able to update the BIOS the normal way, which I think is much safer. Okay, so the first thing you're going to need is a USB drive, and we'll plug it into a separate working PC. Okay, so the first thing we're going to want to do with that USB drive is format it in FAT32. So we can right click on the drive, click on format, and you can see the file extension here is going to be FAT32. So we're just going to click on start and click OK. Now importantly, remember everything in this drive is going to be erased by doing this. Next, we're going to want to head over to our motherboard's page. We're going to click on support. We'll click on the download tab and we'll scan down to the BIOS. And then what I'm going to do is download the latest version of the BIOS. We can head over to the downloads folder. I'm going to right click on the folder and click extract all and extract. So this is actually our BIOS file, which we are going to need to rename. So we'll click on it and we're going to change it to gigabyte.bin. So we're then going to copy this file and we're going to paste it onto our USB drive. Okay, so the only thing we're going to plug into the PC is our power cable. We are going to turn the power supply on, but importantly, we are not going to flip the power switch on the PC. So if we take a look at the back of our motherboard, you'll notice one of our USB ports has the word BIOS written on it. So this is the one we're going to need to plug our USB drive into. So we take a look up at the top of the PC, we've got our QFlash Plus button. You aren't able to get a finger into it. So I'm going to just use the top of a pen to press this button. So just changing the camera angle so you can see this. You can see the orange light flashing here, showing us that the BIOS update is underway. So whenever this light stops flashing, that's going to indicate that the BIOS has been updated. The rules are exactly the same as updating the BIOS the previous way. Whatever you do, do not touch your PC, do not let it lose power because you risk bricking your motherboard. So just stand back and watch. It should take around about 5 minutes. Once the light has stopped flashing, you can try powering the PC on. But the process is slightly different for different manufacturers. So if you've got an Asus motherboard, what you're going to want to do is again download the latest version of the BIOS. And the same as what we did with the Aorus BIOS, we're going to extract it. So it's actually this cap file, which is our BIOS file. And previously, whenever I was updating the BIOS, I used to just copy this to the USB. But when you look at this package now, we've also got our Management Engine firmware update. And that's why when you're updating your BIOS, Asus are recommending you just don't unzip this and you search for the whole file. So it means it can update the Management Engine at the same time. But that's not what we're doing here. We're going to be flashing this using the BIOS flashback functionality. So it's just the cap file that we are going to want, and we are going to have to rename it. So Asus have a BIOS renamer for you. So we had to do this manually on the Gigabyte motherboard. So all we need to do is open this file and you'll notice it'll change the name of this file. I'll just press any key. And now we're back in. So it has renamed the file for us. So all we need to do is copy this file to the root directory of our USB drive formatted in FAT32. And the rest of the process is going to be exactly the same as the Gigabyte motherboard. Okay, so around about after 5 minutes, the light has gone off. Our PC has stayed on, so I'm going to go ahead and turn it off. So that'll look like it went well, although I'm a little bit more nervous by flipping the power switch here than I was with the PC earlier on. I really don't like updating the BIOS this way. The reason I've done it is just to show you how you do it if you find yourself in no other choice but to do this. So I have got everything plugged into the PC exactly the same as the first PC. So we can turn the power switch on and we'll go ahead and flip the power switch on the PC. So that's a good sign. We've got lights on everything, fans spinning. So again, we're just going to have to watch the monitor and hopefully we get a post. There we go. So our PC has posted and is telling us that the BIOS has been reset. So we're just going to click on enter. So what I'm going to do now is get this PC set up similar to what we've done before. Hopefully we'll do most of it off the camera. I'm only going to jump in and out for bits that are different from what I've shown you earlier on. And there will be definitely a few of these because we've got an Aorus board. Some of the software we're going to use and the processes for changing things is going to be slightly different. I'm going to make a start by showing you the BIOS here and adjusting the BIOS settings. Okay, so the first thing I'm noticing that our BIOS update has been successful. We've got F5A installed, which is the latest version of this BIOS. It's picked up our processor, the 9700X, and both our sticks of RAM are showing up, although they're currently only running at 4800 megatransfers per second. We can see our CPU temperature looks good at 32 degrees C. And we can see that all our drives are showing up. This is our SATA SSD that we installed. And we've also got our two NVMe drives both showing up. So we're currently in the easy mode. There is an advanced mode that we can click on, but I'm probably going to make most of the changes in the easy mode. So to enable our XMP Expo profile, we're just going to go down to here and click on XMP1. And we can click on Smart Fan to adjust our fan curves. Okay, so the process for setting up our fans here is fairly similar to our first PC. We've got our different headers here. We've got our current CPU temperature and the current fan speed of the header that we've selected. And we've got our fan curve here with the numbers down the bottom. Over here, we've got our different options and we've got all our temperature sources at the bottom. So you can see our CPU is currently running at 34 degrees. So currently we're on our CPU fan, which is running at a massive 2100 revs per minute. Looking at why it's doing this, so let's have a look and see. So our CPU is 34 degrees, which is round about here. And that means the fans are running probably round about 57%. This must be actually quite quick fans. How we can check is we can go over to here and click on full speed and see what they go up to. So there's absolutely an insane racket coming from the PC. The fans are running at 3200 revs per minute. So these are really, really fast fans. So we'll go back to the normal profile and the noise has jumped right the way down in the background. So I think this is probably where quite a bit of the noise I'm hearing is coming from. These fans are just running too fast because our CPU is going to idle somewhere around about 40. In Windows, which is going to run the fans at 60%, and it's going to go up to somewhere under heavy load to about 60%, so that's the fans running at 70%. And for fans that run at 3200 revs per minute, this is far too high. So we are going to have to set up a custom fan curve. So we'll head over to here and we'll go for manual. And we've got different ways to adjust the fan curves. What we can do is drag the points to where we want them. We have got our temperature along the bottom and the fan speed in PWM along the side. The other thing we can do is enter the values in the boxes at the bottom. So I was actually quite happy with the noise levels of our previous PC, although the fans in this PC seem like they're even noisier. So I'm just going to set up the same fan curves that we had in our previous PC by typing the numbers in at the bottom. Okay, so that looks a little bit better. When our CPU is idle, it's going to be running around about 30% of the fan speeds. And by the time it's hitting up to its maximum speeds, the fans will be hitting around about 55. And you can see our fan speeds have come down a little bit to 1400 revs per minute at idle, which is still reasonably high. We'll go over and take a look at our pump. So our pump is in the CPU opt. It's currently running on the normal fan curve. And as I've mentioned, I do tend to run the pump at 100%. So I'm just going to go and select full speed. It's running off the CPU temperature. It's using the auto detect mode. I'm just going to make sure it's running in voltage mode because it only has 3 pins on it. and you can see our revs per minute are 3,200. If we head over to our case fans, which are plugged into fan header number 4, and I'm just going to set up exactly the same fan curve as what we had on our CPU fan. So we're going to go for manual. I'll leave it taking the temperature off the CPU for now. Okay, so that does look better, and the speed of our case fans has come down a bit as well. So that's me finished now. What I'm going to do is go back to the home page, click Save and Exit. It's going to show all the changes that we have made. So I'm just going to click Yes, and the PC will reboot it. So one difference in the Windows installation is we haven't got stuck at the connection phase where we're having to install drivers. It's gone straight past this and installed updates, and we're ready now to sign in. And I do find this normally in the AMD systems, there's no issues at all with connectivity. It tends to be in the Intel systems where you need the drivers to get connected to the internet, either with Wi-Fi or Ethernet. Okay, so that's Windows installed, and we're getting a pop-up about Gigabyte Control Center. So this is going to let us install our drivers without any difficulty, and it's going to allow us to control the lighting effects on our motherboard, on all our fans, our RAM, and also our graphics card. So I'm going to go ahead and click on Install. So we can click on Next, I agree, and Finish. So for the installation of Gigabyte Control Center, we can accept the license terms, and then we're going to need to go over to the updates. So here we are going to have to be careful because there's a lot of things installed that we're not actually going to want. So I'm going to deselect everything. So we are going to need the motherboard RGB tool, the VGA tool. We'll need our LAN driver, Bluetooth driver, chipset driver, LAN driver. We're not going to need the M.2 graphics driver because we're using a dedicated graphics card, but we do want the audio drivers, and we'll click on Install. Despite making changes to the fan curves in the BIOS, they are not being applied in Windows. So you can see our CPU fans, the fans on the radiator, are back up at 1900 revs per minute. Our CPU op fan, which is where we plugged our pump in, it's no longer running at full speed, and our chassis fans are back up at 850 revs per minute. So the changes we've made in the BIOS are not being applied when we come into Windows. So I've been racking my brain trying to think why, and then I remembered Gigabyte Control Center, which starts running whenever we load Windows, has a fan control mode. So we click on it, we're on our motherboard, and what you can see, it is applying the silent fan profile to all the fans in the system. And as we've already found in the BIOS, with our AIO fans running so loud, this is not what we want. We want a custom fan curve. And you can see our current fan speeds here based on our CPU temperature of 40 degrees. So we're going to have to set the fan curves up both in the BIOS as well as Gigabyte Control Center. So I'm going to click on Manual, and the process is going to be fairly similar to what we've done. We're going to select the fan, so we're on our CPU fan, which is the fans on the radiator. They're running off the CPU temperature, which is the way we want it. And we're just going to have to drag the points on the fan curves so they match what we've set up in the BIOS. So I can't see anywhere to enter the value, so all I've done is drag the points down so we can see our old curve, which we're currently running off. And if I click Apply, it's now going to move on to the new curve, and if we watch our fan speed, they're actually starting to fall. If the speed is still up a little bit too high for your liking, there is potential to make further adjustments to it. So all we would need to do is drag things down a little bit more and click Apply. So that's dropping the fan speed down even further. And I've noticed in the background the noise has gone down significantly. So let's look at our other fan curves. So let's go over and take a look at our CPU opt, is where we have plugged in our pump. It's reacting to our CPU temperature, which I want to keep it on. So with this particular one, I do want to run it 100% all the time. So all I'm going to do is drag up all our points up to 100, and then we click Apply. So there we go, we've now got our pump running at 100%, and then the last one that we're going to have to set up is our case fans. Okay, so it's definitely not as nice as typing the values in, but I have dragged the values down, so our curve has been definitely flattened a little bit. So we'll click on Apply, and you notice now we've got the speed of our case fans falling down. So we take a look over at 64, we can now see that our fans are responding to the rate set by Gigabyte Control Center. And this is one of the reasons I'm not keen on having lots of software running in the background. I wasn't aware that this was overriding our BIOS fan curves, but it's good that I've found this out. So if you are going with this particular motherboard and you are going to install the software package, because you will need it to control the RGB effects on your motherboard graphics card and your RAM, that you're going to know that you are going to have to set up the fan curves in this package as well as the BIOS. So final important step, we have made changes to our fan curve. We have significantly reduced the speed of our fans down. We need to run a thermal stability test to check that we're still happy with our CPU and GPU temperatures. Okay, so thermal testing complete, and you can see our CPU is idling maybe 1 or 2 degrees hotter, but under load it was exactly the same at maximum temperature of 60 degrees. We have, however, significantly reduced our noise levels both at idle and under load. We've gone down by 3 decibels at idle from 39 to 36 decibels and 4 decibels under load from 49 to 45 decibels. Okay, next thing I want to do is show you how to set up the RGB in our system and adjust the custom display on our graphics card. So we're going to need to go to Gigabyte Control Center. You can see here we've got RGB Fusion for our motherboard, our RAM and our graphics card. So we'll go ahead and click on RGB Fusion. Taking a look at our motherboard, you can see the RGB effects are currently set to Wave 2, which is a rainbow effect. We can change the effect, for example, if we wanted to make it a static red. So you'll notice that all the areas of lighting on our motherboard as well as the RGB headers have changed to red. And because we've plugged our IO and our case fans, they've also changed to red as well. If we want to change an individual lighting effect, we can select it. And for example, say we wanted to change that to yellow, we can do that. So you'll notice that one area of our motherboard has changed to yellow, whereas everything else has stayed red. If we want to sync all the RGB, we can click on the sync. And that's going to let us change all the RGB in one go, everything that's plugged into our motherboard. So we can have a variety of different effects. Let's go for a cycle. And you'll see now it's going to cycle through the different colors. There's a rainbow wave if you want multiple colors at once. But the effect I want to go with is just a static white. And I want everything to be static white. And then we've got the brightness we can drag up and down to get it to the correct level for us. So you'll notice the lighting on our RAM and also our graphics card hasn't changed. If we want to change it, we can go into our graphics card and you can see the areas that we have on it. We've got the front, the top and the fans, and we can change these to whatever effect we want, and similarly on our RAM as well. If we want all the RGB to be the same color, the easiest thing is to sync everything up. So if you want to just sync your graphics card and your motherboard, you can do that and have a different color for your RAM. But I actually just want to sync everything, so I'm going to click Sync All. And you'll notice now that all the RGB in the system has changed to white, so that's just the way I want it. Next thing I want to do is set up our graphics card screen, so we'll head over to the LCD panel. So at the moment it is set to off, so I'm just going to turn it on. And you'll see our panel has now come on, but the lighting on it is currently set to rainbow. So I'm going to head back over to RGB Fusion. I'm just going to unsync our graphics card and we'll go in and set it up separately. So I'm just going to select everything on our screen. And I'm just going to set it to a static white. And I'm just going to select everything else and we'll also go for a static white as well. Okay, so we can go back to our LCD panel. And on this, you've got a variety of options that you can customize. So at the moment, our display mode is Enthusiast 2. I'll change that over to Enthusiast 1 to show what it looks like. And we've got a range of different ones. So let's try Enthusiast number 3. You've also got the carousel information appearing. So we can also turn that on or off. So let's try it with it off. So I definitely don't think that looks as good. I think it's definitely better to have the information being displayed on it. At the moment, we've got all the different options that we can select to have displayed. So I'm just going to select them all. And you'll see it's actually cycling through quite quickly on them. Probably too quickly for my liking, and this is the refresh interval. So we can go down to here and we'll set it back to 4 and click Apply. And you'll notice then it's going to cycle through a little bit more slowly. So let's see what else we've got we can add in here. So we've got the option to put a custom image up, so let's try that. So we're going to need to upload our file. So I have put my logo into here, so let's open that. There we go, we can just about get it to fit and we'll click on OK. So that doesn't look great with the carousel display over, but what we could do is drag that display down to the bottom corner, for example. So maybe down to about here. You try the carousel off. The other thing we can do is add some custom text. Aorus is the default, but we can put whatever we want up on the screen. So you are enjoying the video, don't forget to hit the like button and subscribe. We'll see what else we have. So it is possible to also have the carousel information turned on. And again, we can adjust the position of where this appears. And if we want to add additional things into it, we can do that. And then the last one is carousel. And it looks like you're going to be able to adjust a variety of different effects. So it can go from all the different things if you want them to cycle round, and you can change the refresh interval. So you could have the different screens appearing for different amounts of time. We do also have the option here to customize our fans on our graphics card. So here you are able to set up your own fan profiles if you want. So at the moment we're on the default profile. Our auto fan start-stop mode is turned on. So you can see over here, it's really only when our temperature is hitting 50 degrees that the fans are going to start spinning, and this is the curve that they're working on. If you want your fans to spin all the time, what we would need to do is turn the start-stop off. So we need to go to Customized, and let's turn this off. So you'll see this is our fan curve. Our fans are going to spin at a constant low rate. It looks to be about 1,000 revs per minute until we're hitting 55, and then it's going to go up. We can also fix our speed of our fans if we want them just to run at a fixed speed. But I'm just going to keep everything at the default and click apply. So I do like having the fans stopping at low fan speeds. Okay, so that's our two builds complete. Let me know in the comments which one is your favorite, and hopefully it wasn't too confusing me building two systems in the one video. The idea behind it was if I just made a single build guide and showed you how to build one group of parts, I do 25, 35 of these every year, you could just follow along to it. The reason I've chosen the two different systems with as many differences between them as possible was to show you the options so that you could decide why you might want to go one way or the other, and if you did want to go that way, how to do it. So over this system, we've gone for premium motherboard, premium CPU, premium graphics card, premium cables, to give you an idea of what that is going to look like. Even the cooler, I think it's about £400 for this AIO. Whereas on this side, we've gone for more budget options. This cooler is less than £100. We've got an older generation of motherboard. We've shown you how to flash the BIOS using the BIOS FlashBack functionality. And I've also shown you back connectors. And again, one system with AMD, one with Intel. But hopefully now, if there's bits and pieces you like from each of them, you should be able to piece them together. So an important question to ask is, now that I've built the two systems, would I go back and make any changes? The Lian Li system, I'm absolutely delighted with. I think it looks stunning. The RGB set to white looks great. And in the default fan curves, everything is lovely and quiet, and I'd be very happy with this sitting beside me on the desk. So because of how the cables come out of the power supply facing the side of the case, the best way to manage them is up using the Velcro cable straps above. So those bulky braided cables weren't as easy to manage if we've gone for cheaper, flatter cables. So that would be one thing you could consider changing. Likewise, if you wanted to go with much cheaper components, I think this would still look fairly well in this build. In fact, I am using this case as my second system. I've got Noctua's NHD 15 and with no RGB in it, and it actually looks pretty good. So moving over to our Phanteks system, there probably is a few more things I would consider changing here. Certainly, as I mentioned when I was installing it, a white graphics card would go much better in this case, but I was keen to show you a latest 50 series graphics card. If you did want to pull the black and white theme off, what I would suggest is a black motherboard with the black graphics card, and that would work very well. You probably noticed at the end of the video I struggled to get the steel design panel back on again. There's a number of reasons for this. The mechanism that Phanteks use for securing it isn't great. There's 3 pins at the top and 3 at the bottom. You have to get them all lined up perfectly to be able to push the panel into place. And because we've got back connectors with all the cables coming out towards the panel, it was difficult to get this panel on. I actually had to go back and remanage some of the cables. So the 8-pin EPS connector at the top, I had plugged the bulkier cable in. So what I did, I unplugged this and plugged in the furthest daisy-chained connector, which had less cable coming from it, and that helped reduce the bulk of the cables there. And I had to remanage all those cables in the middle with the Velcro cable straps, particularly the 24-pin cable was sticking out. So I did my best to make sure there was no other cables behind or in front of it when it was running. So after doing this, I was happy that none of the cables or connectors were putting pressure on the back of the case, and it was just an awkward mechanism for securing the back of the case. So in terms of doing a back connector build, the actual plugging the cables in itself was really straightforward, but I would say for a back connector's case, space at the back is tight, and then combined with that difficult mechanism for securing the side panel, as a first-time builder you might struggle a little bit in this case, and you might want to consider going with a standard motherboard where the connectors plug in to the front. That's going to give you more choice as well. You can go for one of the B850 motherboards, so a more modern chipset with more modern features. And again, if you take a look at this case, actually, none of the cables plugging into the front actually look that much worse, although here you are going to improve the aesthetics. So you're just going to have to decide, is the improved aesthetics of a back connector motherboard really worth it for you? I think for a first time build, I would probably recommend going with a standard motherboard, and you can build with a standard motherboard in this case. So the final thing I'm not happy with this system is the idle noise out of the box. So the motherboard fan curves all run in their standard fan curves in both systems. So what I'm going to do is I'm going to move the microphone over to the two different systems just to let you hear the difference with both systems at idle. So the majority of the noise in this system is coming from the I/O, so I'm just going to stop the fan blades and let you hear. There's two problems causing this. The first is actually the fans in this I/O just spin really fast at 100%. So whenever they're running at 40% at idle, they're still spinning really fast and making lots of noise. The second thing is the way the default fan curves go in this motherboard. They start off at quite a fast speed and they actually reach 100% really quickly. And the Ryzen CPU tends to idle around about 40. And it's going to be going up to 40 into the 50s and 60s while the PC is doing background window tests, and that is approaching pretty much close to the full fan speed in this AIO. So a loud AIO combined with not the best fan curves is a bad combination, and that's why there's so much idle noise in this PC. So I think for a first-time builder, you're not going to be able to leave this system as it is like you could with this particular one. You are going to have to go in and customize the fan curves like I've shown you in the video to reduce that idle noise down, because I would not at all be happy with it sitting beside me on the desk. So again, if you're doing your first build, that may not be something you're going to want to do. And to avoid that, I think if you are going to use this motherboard, you are going to have to customize the fan curves anyway. I think the fans run at 40% at idle is probably going to be a bit loud unless you've got a really good CPU killer. So I would consider going with a slightly different AIO, or what you could actually do is pick yourself up an air cooler. The reason I was so keen to do an AIO was because we were doing a back connector motherboard, and it wouldn't make sense to do this where you've got a lovely motherboard without any connectors and hide it all with a big air cooler. So you went with a standard motherboard, that would solve the issues with the connectors at the back, and put an air cooler on, and I think the idle noise would be so much better in this system. So while I think both these cases are absolutely stunning and perfect choices for a first build, they may not be your cup of tea, and you might want to go with a smaller ITX case, maybe a bigger full tower case, or maybe you fancy one of those fish tanks with lots of reverse blade fans. Well, I do about 25 full step-by-step PC build guides every year. So take a look at my other videos. If these cases aren't your cup of tea, you'll probably find a build guide for a different case that you like the look of. If you have enjoyed this beginner's guide to building a PC, please remember to give it a thumbs up, drop me a comment, and if you're not subscribed to the channel, please hit the subscribe button as well. Thanks for watching.